So it looks like a lot of you found it interesting, not hard to access or confusing, so that's a good sign. Sometimes there is some confusion with accessing the lab. Just like yesterday, I would like to understand how well you understood the content. For the one person who's done this, maybe you should come out here and help me deliver. Because no one can be an expert at everything. Utilize everyone's skills the best you can. So that's a good sign that no one's over in this area here. If you've still got questions, now is your time to ask those questions. So let's see what questions there are. Now you can ask verbally if you want, or you can just type your question into that. While we're waiting for questions to appear, has anyone heard of a website called Humble Bundle? Humble Bundle is a basically originally started for gamers. So Humble, if I spell it right, humblebundle.com. And the idea is that you can buy a group of games at the start, and that money goes and gets donated. They now give out ebooks and online training. So this week they've just released one for cybersecurity. It's not their best one, but if you click on that, it's got a whole heap of cybersecurity ebooks that you can buy. And up the top it shows 18, 10 or 3 of the items. But if you click on the number there, it tells you what it is here. Now the disadvantage is we're in Sri Lanka, so it looks like it gives us US pricing, so it's quite expensive. Whereas in Australia, I get AU pricing. So it sometimes works out cheaper. So if you know your VPN technologies, it might help. The other option, I wouldn't get this bundle, but there's some that are quite good. They have programming books, all sorts of things there as well. So it's asking, can I show us a live capture of others' traffic using Wireshark, in particular the workshop Wi-Fi? So yeah, I can do that. So you need to connect to that Wi-Fi, and then actually, do I have permission? Am I allowed to do what? Who's control of the workshop what? Is that just localized to this room? So there will be a couple of things to do it, but essentially what you need to do is make sure you're on the correct Wi-Fi. So I click on workshop. Can't remember if I've got the password still. So I'm now connected to the workshop. I open up Wireshark, and when I first open up Wireshark, you'll see up the top is your recently opened packet captures. Down the bottom are the interfaces on this system. If it's able to recognize network traffic, you'll see this, what I refer to as a heartbeat. See how it keeps growing? So that means I can listen to the traffic on that. If I don't see that heartbeat, you may need to enable the Wi-Fi packet capture, and you may need to go into the refresh interfaces there. But under options, if I click on options, it's going to give me details about that interface. And then I can go down to manage interfaces, And this is going to change based on whichever system you've got. But the main thing you need to be aware of is this tick button here, enable promiscuous mode on all interfaces. Promiscuous mode is what is needed to be able to listen to other people's traffic. I've got that enabled, so I then click on close. And essentially, to start capturing, I just double click on this. Now, before I start, what I can also do is I can apply a capture filter. So if I'm troubleshooting a client's system, I find out what their IP address is, and I will only capture traffic for that system. That way, I'm not grabbing someone else's traffic, especially if I'm going to be putting that into my ticketing system. Whereas if I just want to start listening to everything, I don't put a display, a capture filter on there, and I just capture everything. And now I'm getting traffic for all sorts of networks. So we're getting lots of information being sent. So someone's sending a lot of ICMP data. And then I click on stop. Now I've only let that run for a little while, not even a minute. And I've got over 6,000 packets captured. So I'm getting quite a lot of UDP traffic. So I'd be investigating that. Why am I getting so much UDP traffic? And it's on weird ports. So that is definitely a bit of something that you need to look at. Oh yeah, yeah, it would be Zoom because I'm trained. Yeah, it would be Zoom. So yes, that would be the case. So it would be encrypted, so I wouldn't be able to see it, data truncated, and yeah, it's encrypted, so I can't see it. So yes, it would be Zoom because it's a streaming service of some sort. Most streaming services now use UDP. And we can see here that there is encrypted traffic there. Now, there is a technique where I can get the session keys from a system. In the lab guide for Wireshark and T-Shark, I talk about how you can do that if you are interested. But that's it. That's the simplest way of being able to capture a packet on the workshop Wi-Fi. I'm just going to change back. So that way I'm on the same network as everyone else. How to scan multiple PCAP files. Wait until this afternoon. We use TCP dump to basically look through a directory of PCAP files for clear text passwords. So we will go through that when we do our security onion. Creating a testing environment using a VirtualBox is secure for practicing Kali Linux tools. Is that a statement or is that a question? So depending on how you set it up, in VirtualBox, you can set it up so that way it's only a local host connection, meaning there's no outbound traffic. So that's usually a safer thing. But there are techniques that malware can use to escape VMs or sandbox environments, or there's techniques in malware where it detects that it's been run in a sandbox environment and it won't run the payload. So most of the time it is safe to do it. What you do is you set up your connections in an isolated environment. Like the lab environment that we've got up on the Academy, there is no internet connection. All it is just a local area network between three machines, Metasploitable 2, Metasploitable 3, and Kali. I'll put some links later on so you can download the OVA or the VMs to be able to import into VirtualBox. For the person who asked about the multiple PCAPs, if you open up the lab from the TCP dump and scroll to the bottom, here is an example of what I'm doing. I'm using a for loop, and all I'm doing is doing a directory listing of a folder with packet captures in it. And then with the for loop, I use TCP dump to replay that capture file. And then from there, I'm looking for a particular user agent strings and I'm pulling that out. That's a more advanced one there. Or up here, I'm pulling out these keywords: password, login, user, username, and password. And it's basically doing the same process for clear text type of traffic. So HTTP, FTP, SMTP, IMAP, Telnet, POP3. But we'll go through that a bit later on. Any questions about what we've covered? So I have updated day 3 slides. I actually combined them into one just to make it a little bit easier to follow along. So yesterday we did a very manual process of doing packet analysis. So we used T-Shark to open up a packet or replay a packet, and then use some of the Linux commands to drill down into specific parts of that packet capture. Then we used Wireshark to use basically a graphical user interface to do similar tasks and do discovery of that. There are open source tools that help automate that process. And the idea of an intrusion detection system is that it tries to look at your traffic as it goes across the wire, looking for particular behaviors or signatures, and then it's going to give you an alert about that. You still need a packet capture to go and do further analysis, and we'll look at that later today in one of the labs for Security Onion, but that's essentially what we're going to be focusing on today. Building on those skills of yesterday of doing the manual packet analysis to hopefully using tools that help automate some of that. I'll just start my slide deck.
Hi. So far we discussed different techniques, how we can harden our systems, and how we can prevent some hackers or some outsiders enter into our network. So even that, our all the implementation there might be can some loopholes, right? So hackers or whatever the outsiders that they want to steal our information, they also kind of intelligent people, so we never can be undermine them. So they also trying their level best to enter into our systems and steal the information. So intrusion detection systems is one kind of a tool that we are going to use to the monitor those things. And as Varun said, that we have done this same thing using different techniques yesterday. And I think you know that we have to capture the TCP traces and TCP dumps and analyze the packet manually. It's a bit hectic task. We have a lot of equipment in the system, lot of connections, so debugging into all those things every time, it's not possible. So we have these tools, Snort and Suricata, and there are a lot of other tools, and some we have to pay and get the license and implement in the systems. Some are open source. Yeah, we'll be discussing here about these two intrusion detection systems. So we'll be going through that IDS, IPS, intrusion detection and intrusion prevention systems, and that we call IDS and IPS both. and there are several types of detections, and then we'll move to this tool side. So we discussed about the vulnerability assessment yesterday, right? So if from the vulnerability assessment, we are identifying a lot of vulnerabilities. Maybe it can be a scheduled task or real-time task, or even that means scheduled every day, or most of the time it will be periodical schedule. So what will happen when the some 0-day attack comes? We don't have any identification mechanism in prior to that, and even we identify the vulnerabilities, or it will take some time to fix. We have to analyze that impact, and then we have to plan the upgrade, especially OS patch upgrade. Like sometimes we are getting more than the OS side. If it is goes to application side, like with the versions, Java kind of things, those kind of updates, if it comes, I think we will need some time to analyze that impact and implement those. So they are not, so the patches will be not fixed at the promptly. Right? Maybe sometimes we are finding situations like when it is comes with the big networks, even we apply the patches, there are some servers we have to left behind. So those can be some weak points. So human mistakes also can be involved, right? Some kind of like bringing external devices and plug in there, and inside the organization, some employees, maybe there are behavior issues, and maybe some angry employee leaving the place, and still he's having access to the devices, and those kind of things can happen. And during the penetration test also, we never can expect that all the things are detected, because some, because these tools we are running with the whatever the updated data, maybe it can get some time to update. So we cannot make sure that whatever the defenses we are putting are exactly correct. And sometimes we are filtering packets from the firewalls, and we maybe still we are allowing some external traffic. Maybe we can't filter all the traffic, like if you are connecting to internet and some that means big network to network connections, if you are facilitating those things, then we can't restrict all the IPs sometimes. So in that case, all these defenses are temporary only. I mean, they are not exactly 100%. We can tell that, yeah, we have implemented all the defenses, yeah, now our system is safe, yeah, we'll stay like that. We can't do like that. That anyway can get failed. You know that in it is like in Sigiriya, King Kashyapa built all the defenses around this rock, but it's castle, but still troops get into that. It's something like that. Still we have chances. So to prevent those things, we need some detection systems also. That for that we are using the IDS. It is like we have all the mechanism, but still we are watching, yeah, who's coming here and going there. Real-time monitoring we are doing. So this IDS, what they're doing, there should be some suspicious behaviors, like someone is trying to log into system with a failed, that means incorrect password for multiple times. Then we can instruct our IDS to, yeah, if someone is trying a lot of logins, because it is abnormal, right? If it is inside employee, one time will be trying, second time trying, maybe he will be getting the password reset option or something, some help. But if someone trying to external tools or something, we will detect a lot of trying. And some other things are the abnormalities, that abnormal behaviors. One thing is strange behaviors, and some things should not exist, but it is there. We can find some strange things. And other thing is what IDS is doing, there are known behaviors. When we discussed about the attackers cycle, when we are talking about the penetration test, that attacker is not getting into the system at once. It's not just like coming and getting into the system. He's doing some main pre things to enter. He's doing his own researches and checking the all the network. I think you simulate that one using nmap command also, and using those techniques they are doing the overall that background study. So that time itself we can identify those patterns, because the technology is same for the when we are using for the prevention, and when we are doing for the our simulations, and also for the attacking, the technologies is the same. So we know those known patterns, right? So we can, based on those known patterns, we can configure that IDS to identify something strange is going on. You have to aware of this one and do some actions, right? So then this way we can, based on the instructions we are giving to the IDS, and whatever the history experiences we have loaded there, and it can identify the good or bad traffic. So we call it tuning. That means all the IDS systems time to time tuning is required, because the technology is updating. We have to update our tools too. Even it detect the whatever the risk or abnormal patterns, IDS system itself can't act. Right? Only thing is, it can alert. These are the things happening around me. Please look into that. As per my configuration, it is some suspicious behavior. And IDS itself also can't act, because some human intervention is required, because we have to program it and tune it, and that should be based on our organization security policy, and we are doing one kind of a security policy and implementing IDS in another way. So there's a conflict that IDS itself can't read it.
Let me just reiterate a couple of things. So in regards to the previous script, we're looking at abnormal behavior. How many of you know what your network baseline activity is? So ideally, if you install a brand new network, you should know what sort of systems are connected to it and what sort of traffic should be going across that network. If you're unfortunate where you basically join the network and it's an ongoing existing network, make sure you get a baseline. What is normal traffic? How much workload is being across the wire? And then what is normal in regards to should teachers be able to access accounting and payroll information? If we're looking at university. That's where abnormal behavior comes. You're able to get isolated. So this machine in this classroom shouldn't be accessing the accounting payroll server over at the different school. So that becomes abnormal behavior. So that's what you do there. In regards to compensating for weak authentication, on day one, I showed you that website, Have I Been Warned? And players get an email address and see if it's been compromised and in a data breach, give a list of the passwords. So if you've got your IT person or anyone that has a login to your system, and someone's able to get a username and password, it can look like a legitimate attack. It's not going to be able to do that. But if they log into the system, this machine here, and then they go and access payroll, that is abnormal behavior. That's a protected login at capital. In regards to weaknesses in network protocols, Telnet. It's insecure, isn't it? So it's not going to work on Telnet, people selling patents to your network. That makes sense. And in regards to strange patterns, I might get an alert about someone accessing the payroll server. So I still need to investigate who was on this machine. IDS may not do that. That's what we're referring to there. And from an organisation security policy, that is an administrative control. It's a document saying you will be logging in 9 a.m. to 5 p.m. using a complex password. You can't really tell the IDS here that this. No. You're going to have to do the technical side of things and interpret it. And you're going to look for traffic outside of those systems from this machine. You're going to look for passwords that that makes sense.
Thank you, Varun. Here the points that we can implement the IDS. When we consider about the network, here these are the hosts in the network. There are some controls, and then it's connected to internet. So from the host level, there will be host IDs, and there will be specific monitoring kind of things we can define based on the what is the use of each host. And but when it is going to internet side, those will be network IDs. There will be some generic configuration because we don't know the what, because here all the hosts together are communicating to the internet. So maybe these hosts might have different services, but when it goes to internet side, it will be all the combination of all the things. So there will be more generic aspect of IDS will be happening in internet side, but when it comes to host side, there will be some specific detections will be happening.
Just to clarify, I'll get you that one.
Yeah.
So the idea is when I implement intrusion detection systems, where should I be monitoring my network? Should I only be monitoring one location, or should I be monitoring multiple locations? Now, in regards to that, comes back to your licensing. If you're going to buy a big, expensive intrusion detection system and it's going to cost you $1 million to run it, probably only going to run it in one point. So you'll find where your exit point is and you'll run it there. But if it's an open source one, you would run it in multiple areas. And the idea here is that you have a generic firewall or intrusion detection rule closer to the internet and further away from the more specific. Usually what you want to try and do is to stop the traffic at the source, if you can. So, example would be, if I don't want Telnet going across the public internet, I would put a Telnet rule here. However, if one of my machines get infected with malware, I don't want it scanning the network, do I? So I would put it on the host IDS to stop or alert and then stop that traffic. Does that make sense? So the idea is that you do generic type ones, block a particular port, block a particular protocol. This one is more specific. This user can only connect to this system.
So in when we consider particular organization, yesterday we discussed we are classifying the assets, and so the network, in the network hierarchy itself, we have to implement this node level IDS. So whenever we are getting alert, it's easy to identify which node. If we which node it is giving this kind of this alert, and we can do some prevention action. Maybe the isolate that particular node, or block that particular node. Some ports we can be blocked, kind of actions we can take based on the each node. So this in the when we implement it in the organization, there will be a main intrusion detection system and will be agents in the all over the host. There are different types of detections we can implement with this IDS, and one is signature based and anomaly based, darknet, and honeypot. So signature based means that it will be a signature database in maintaining with the IDS system. In the IDS system, there will be a database that already identified behaviors, right? So whenever some issue is happening, that threat intelligence systems, they will be identifying those signatures and putting into that intrusion detection databases. So we have to identify the we have to update our systems periodically, and to get the all the new things. Security solutions are always expensive. It's like to implement that, maybe we are using open source. If we are getting licensed ones, then they will be always expensive. But we are spending a lot of money and implementing the system, and now we are thinking like, now we have done everything, defense and detection both, so we are safe. And we can't wait like that. We have to make sure we are doing that regular updates of that. Otherwise, recent attacks patterns kind of things we can't detect with our existing IDS system. So these updates always required, and this anomaly based also. Now they are using kind of AI technology to do some predictions based on the previous patterns. They are predicting some new patterns too. And other thing is darknet, and it is monitoring all the IP addresses, and they are finding some darknet IPs, and whether they are suspicious IP addresses or not. Based on that, in that aspect also, it is doing the detection. And honeypot is a trap. Yeah, whenever.
Reiterate. So everyone has recently, the past 2 years, darknet has been associated with this bad part of it. That's not what we're referring to there. What we're referring to there is that you get allocated an address block. You may not deploy all of those addresses at once. So what you could do is set up an alert to see if anyone's trying to connect to any of those IP addresses that you haven't allocated yet. Why do you think you want to do that? When someone compromises the network and starts using that. There's been lots of cases where people go to who is and they find address blocks that aren't used and they start using those. And there's been legal cases where this company goes and start using them, which rather than legitimate owners, but these other people have used them for decades. And there's an issue there. The other thing is, if I'm using Nmap, and I'm just going to do a scan reconnaissance, they may be scanning those IP addresses. So you get alerted to that someone's trying to do reconnaissance on that. So there's various reasons why to do it. So, yes, it's also now a good idea to look into the darknet to see if there's any credentials or any other compromised activity on the system. But in most cases, that's going to be expensive. But we're referring to the prefixes that haven't been assigned anywhere.
Yeah. And honeypot is a trap. It's like we are putting that target, that similar to the target, we are putting a system. So attacker initially is getting into that trap, and we can identify that behavior. Like if some attack is coming from the outside, as it is the easiest one to get in, that attacker will first get into at that place. So from there we can identify what is the activity pattern of that particular attacker. So based on that also this IDS system can be tuned and it can identify. So it is basically to understand the attacker's methodology. Different attackers will use different things. So based on those techniques, we'll be identifying the intrusions and can post the alerts to the system administrators using the system. So here the IDS technology landscape, if we are talking about that, there are networks and systems are there, and we have the preventive mechanisms like vulnerability assessment and real-time things to identify the do the intrusion detection. And it's a real-time monitoring thing, and vulnerability assessment is it's a scheduled thing, and it will be the preventive measure. And system side and network side both there will be IDS and vulnerability assessment, and network based vulnerability and network based intrusion detection will be there in the network side. And we discussed that related that closer to internet there will be a network based, and when it is come to system and near to the host center, it will be and host based intrusion detection and host based vulnerability assessment. That I discussed that I mentioned that we have to send the alerts whatever the detected intrusions from the IDS systems. Otherwise, the system is there and no one is getting to know. It's like alarm, and there should be notification or email alert, SMS alert, or that normal alarm system can come, and that alerts will be depending on how we are going to tune the system. And we can that too strict or too loose waves we can do the tuning of the IDS, but if we go into too strict mode there will be a lot of alerts, then we will be missing some important ones. It's just like alarm guy might have said that there are a lot of alarms in similar categories, so I couldn't identify that this particular one. But when it goes to too loose mode, maybe we are missing some kind of. So we have to balance based on our existing network behavior and do proper tuning. And network admin, of course, he should have better understanding about the network when they are going to implement this kind of solution. Otherwise, we will be missing some important alerts in either case. Also, we can't make sure that all the alerts coming to our system are positive. We can't get like that. So false positive, also false negative, we can get. So the my system might be raising some incorrect alerts and incorrect rejection and some hypothesis when we are implementing some it's a programming logic, right? So it can be lead into some hypothesis mismatching when we are running it with the complex programming. And false negative thing that we are not detecting some attack, we can be missed when we are configuring that based on some this false positive false null hypothesis. And this also possible. So the detection system, we have put in the detection system that also we can make sure that it is 100% accurate. Still there are chances, but as per the way we are tuning it and the way we are implementing it, we can keep trust on this will prevent whatever the attacks, and it will be identify the all the attacks it's coming. So when it comes to ISPs, what they can do is they can protect they can monitor on network, and also they can implement into their customer networks. But when we are monitoring in the customer networks, there can be a lot of constraints can come, because customers can be some finance situations, financial institutes, and some secret data should be there. So they might be scared of putting, like if we are doing some port mirroring kind of thing, we are trying to get that traffic into these IDS systems. So in that cases, there can be some obligations. No, we don't want to send our traffic to you, that trust issues also can come based on the understanding. And but it's always good to have this kind of system. If an ISP level itself also can do some protection towards their enterprise also, but it has that other aspect also. Yeah, this SNOT is one ideas that we are using since a long time, and Suricata is that new one replacing the SNOT. And how we are going to implement this SNOT and Suricata in the network, we have to get the whatever our network equipments involved in that, and we have to configure those things, and with some samples, I think Warren will be conducting that part.
So Snort actually is a project that came from another project that was developed in the late 90s. The project was called Shadow, and in about 2000, 2001, it then stopped being developed and it got merged over into Snort. Snort has been around for over 2 decades. About just before COVID, Cisco purchased Snort. But as part of their commitment to the community, they said they will maintain an open source version. But there is now a commercial version of Snort that you can get. If you need a support contract, you can then pay Cisco and they will help you with that. So it's been around for over 2 decades. There's a active development community. So the community edition, you get the rules updated 30 days after they've been released. So you won't get them at the same time anymore. However, because it's open source, you can write your own rules and modify those rules to your heart's content if you want. There's also a mailing list where you can ask for assistance if you don't understand, and there's plenty of documentation around for that. You do need to set it up correctly, and it's a lot of manual fine-tuning. Has anyone ever set up a Cisco ASA firewall or some sort of intrusion detection system in the past? One person. Okay, you can come up here now. So in regards to intrusion detection systems, there's different mechanisms for it, but ideally what you do is that you don't implement it and on day one start enforcing the rules. What you need to do is to fine tune it. So you put it into what's called a learning mode, and from that learning mode it gets a baseline of what's normal for your traffic. So a lot of the vendor equipment does that very well. In regards to the open source software, you have to do a lot of manual fine tuning for that. So you start looking at that, let it run, and so on. So you can run it as a intrusion detection system, or you can run it as an intrusion prevention system. So intrusion detection system means that it's just going to monitor and alert. Intrusion prevention means that it's going to stop that traffic. So that's why you really need that learning mode, just in case you get false positives or false negatives. So you can run it in different ways. One, you can run it inline. So basically you put it on the wire, you've got 2 interface cards, one coming in, one coming out, and it's just inline, just like a normal gateway would be. That then means that you can do it as an intrusion prevention system if you want. But it also means that it's a single point of failure if you use it that way. The other thing is that you can put it in front of your firewalls, because it adds, you get a lot more alerts though, because you're going to see all the bad traffic that your firewall's not blocking. So that could be an issue there, but it comes back to if you're into research or not. And then the other way that we tend to use it most is more as an intrusion detection system for monitoring. So you basically are sending some sort of traffic to it and it's off to the side. So it's not in line, it's not disturbing the path of the traffic, it's just getting a copy of that traffic. You can do that a couple of ways. You can use a switch and you do a port mirror. You could do a physical tap in and send it via a physical tap. So depending on what you're doing, you cut into the cable or the fibre and you split it off that way. And there's also physical hardware that you can use for splitting traffic. So you can use a switch, one port to another port, a group of ports to one port, or an entire VLAN. Things to be aware of if you do that is that you don't want to flood that mirrored port with too much traffic, because if you overload that switch port, you're going to drop packets. If you drop packets, you may not be able to alert on them because you're not seeing all the malicious traffic. So you need to think about that as well. In regards to Snort, it's a big configuration file. It's over 900 lines of code in the configuration. So you can modify a lot of things in there. The way that it is fast is that it's got what's called these preprocessor engines. And it's certain parts of the networking stack and the memory stack that it will be able to handle efficiently, and it processes those packets very quickly. And the idea is that it's basically pre-compiled these for you. It then basically monitors those packets for the suspicious activity, and if it matches a detection rule, it will alert on that detection rule. The rules are just plain text files and they're stored in this location here. Now, depending on your installation of Snort, there are a lot of packaged software that will move it to a different directory. But normally out of the box, if you're just doing a straight Snort installation, it will be located there. Later this afternoon, when we're looking at the Security Onion tool, it's moved those rules to a different folder. What we can also do is that we can update our snort.conf file that we talked about here to point to a different location of where the rules are stored as well. But the idea is that you're going to create your rule set, or you're going to use the community rule sets, or you're going to get the commercial rule sets, and they're going to be looking for particular things in your network. It might be a set of IP addresses. It might be activity related to a port scan. Might be a web address that it's going to. So you can look at URL filters or particular keywords that are found inside a packet. But essentially what you want to do is to turn on Snort, go have a look at the rule set, and then determine which rules are applicable to your network. If they're not applicable to your network, then disable those rules. Or you could leave them on, just don't do the alerting. Send them to a log instead. As I've said, it's commercially maintained by Cisco. Volunteers also create a listing of rules here where you can go get them. Now, to keep your system up to date, it's a very manual process. So someone went out and wrote a tool called Pulled Pork. And that Pulled Pork tool is a script that can go out and connect to those repos and download the latest version and apply those to your system. The reason why it was manual in the past is that you may have gone through and customized your rule set here, disabled some of those rules. When it does the update, it applies the rules over the top. So it goes back and enables all those rules that you have disabled. So that's one thing you just need to be aware of. When you are doing updates, what rules are enabled, what rules are disabled, and what rules are suppressed. And so you'll need to modify that. We're not actually going to install or use Snort today, but I'm giving you an intro to it. But essentially what you have when you create a Snort rule, you have a rule header and a rule option, or more than one option. And that's the same for Suricata. So the rules setup is very similar. Suricata is essentially a fork of Snort, and it's changed a little bit. In the rule header, it's going to have things like the action, the protocol, the source and destination address, the source and destination ports as our information to search for and to start alerting on. The rule options contain the messages and the parts that you're searching that packet for. An example is here at the top. We've got action, the protocol, IP address, the port number of the source, the direction of the traffic going to this destination IP, this destination port, and your rules with one or more options. So here's an example of someone trying to log into SSH. So we've got alert, TCP, and in this case, it's got a variable name called external net. So if I want to do more than one IP address, I can create a variable in that Snort conf file that allows me to have those all listed as external. Any port going to my home network on port 22. And so what I get is an alert message saying SSH detected, and this is the Snort ID and revision. That's in its simplest format. Some of the actions we can do alert, log, pass, drop, reject, or sdrop. So if we're going to act as an intrusion detection system, we can add these as our type of action. If we're doing it as intrusion prevention system, if I'm doing it as an intrusion detection system, I'd probably just do one of these two. Most cases, you want it to be alerted somewhere. The direction is where the traffic going to and from. In most cases, you're going to stick to this one here. There is no one coming back, so the destination to the source, but you've got bidirectional if you want. The Snort ID, there is a guide on what you should do. So anything below 1 million is reserved for the Snort rules. Anything above 1 million are your custom rules that you can create. So you can use any ID you want, but just be aware it may clash with some of the existing rules in the rule set that you download. The revision number is optional, and all it is a way of you keeping track of that rule set. You might fine tune it, and so you go to revision 2. You then make another change, go to revision 3. That's the idea behind it. When you start building out lots of alerts, what you can do is try and group the alerts together based on a class type. So the class type might be web attack, DDoS attack, something like that. And then you can create a custom classification in this file here. And essentially what you've got is 3 fields. You've got DOS as the class name, the short abbreviated version, the class description, denial of service attack, and the priority. And that's going to have a number between 1 and 4. 1 being the highest priority means that it's a problem, please fix it straight away, and 4 being low priority. And so when you send this to a logging system, you can group like alerts together if you want. And we'll look at that this afternoon when we start playing around with Security Unlit. Here's another example of another alert. Alert protocol is TCP from any external IP address on any port. going to my home network on any port. And in particular, I'm looking for the TCP/UFPU, so Fin Push Urgent Flag, and it's basically a Christmas tree scan attack. So the idea is when I'm scanning a network, I set those 3 flags, and it basically is going to masquerade or trick some systems into not recognizing what's happening. I've given it a SID of 1,000,002 and revision 1. And this one here is flow type is stateless, meaning that I don't need to establish a connection. So if you think about the TCP IP, if you look at NetStat, it shows you what sort of connection is created. So you've got established, listening, and so on. It doesn't need to be established. That's why we've got that there. This one here is a web alert. So basically any IP going to port 80, but in particular, they're going to a URL with a /admin in the path name. And so what I'm trying to do is someone's trying to find my admin portal to my WordPress site as an example. And so they're basically, I'm checking the web address, see if it contains this. And if it does, I'm going to set out a warning. And then I've added it to a class type, web application activity. These are simple formats. You can get a lot more complex. So you can look at hex values in the content. You can look at all sorts of things. So here's my flow to server established. And in this case here, it's looking at the MySQL. And there's a typo in this one because I've got certain things missing up here. Can everyone see that? So I should have put this line up there as well. But we've got this MySQL show database attempt, MySQL 40 root login attempt, and so on. So it's doing a lot more complicated setups there. And in this case here, it's actually looking for certain words within close distance between each other, in particular the root within 5 and the distance of 5. So it's a very complex rule, that one is. If you're new to playing around with Snort and creating a rule set, someone has created a nice little GUI that you could play around with. Now, they used to have a web version that you could just connect to the internet and play with it. They obviously had too many hits on it or something, but you now need to install it as a Docker instance, and you can go and get that there. So I'll leave that there if you are interested in playing around with it. I've put a link in there for a virtual lab that you can start up and then try and use it. Some other references there, some great documentation on how to write rules are here, and also understanding those rules because Rapid7 helped promote the Snort. And this is where we're going to start talking about the Suricata intrusion detection system. So it's from the Open Information Security Foundation. It's been around for, I think, about 2008, but it's another open source project. What we hope to look at today using the labs is getting an introduction to using Suricata. So looking at the functionality, the features, and getting it set up. Then we're going to start looking at some sample malware and packet captures and try and do threat detection using those. And we're going to update rules and signatures and hopefully get alerts based on those packet captures that we've got. So it was released in beta version 2009 and the official version July 2010. So it's just over a decade old, not as long as Snort. Snort's more than 2 decades old. The big advantage of Suricata over Snort is that it's multi-threaded. So a lot of the security professionals started to move away from Snort, especially after Cisco purchased it, but also around 2016 it became very popular. it allowed you to output some of the standard information and alerts as a JSON format. It can also do other things like looking for particular files in a packet capture, logging those files, extracting them, and also doing an MD5 checksum. And you do that to then upload to various vendor sites to find out if they are malicious. And we'll do that soon. Just like Snort, it can do IDS, intrusion detection system, intrusion prevention system, but it's also packaged in a lot of tools to do network security monitoring and being able to replay that packet capture if you want to. It allows you to obviously inspect the traffic, and you can also write your own scripting or any sort of extensions to the Suricata using the Lua scripting engine. Wireshark supports Lua scripting engine as well. So if you are a researcher, that could be an option for you. It also supports output to YAML and JSON, which means that you can now take those logs and import them into your security events and incident management tool, whether that's Splunk or something else, Graylog, Elasticsearch, Kibana, and being able to then visualize that information. And we'll look at that a bit later on. Actually, we may not. We'll do it with Snort this afternoon. To install Suricata, we're going to need a Linux system to do that. So I've got to reset our Linux server, so I'll need about 5 minutes to do that. In regards to resetting the Linux system, once it's reset, you're basically creating a directory for your downloads, changing into the downloads, and you're basically adding the Suricata repo, much like what we did with Wireshark yesterday. And then once that's added, we just do an install of Suricata. Once we've got that installed, we're then going to add the EVEBox tool, and we download that directly from this website, and we then use the package manager to install that install file. Then we can also add in our JSON query tool, which we'll need because we're using the command line at this point. Yesterday, we used the command line first, then we went to a GUI. That's what we're going to do today. So Suricata is a command line tool. EVEBox is a GUI for that command line tool. So we'll go through that. It's 10:30. Oh, good time to have a break, and I'll reset the servers. When we come back from the break, we'll start looking at how to install Suricata. Yeah. So if you don't see Winget update, it's because you're running an older version of PowerShell or your operating system hasn't had it installed. So you then just do a search on your friendly neighborhood search engine about how to install the commandlet Winget. Because I remember on my previous laptop, I had to manually install Winget, whereas with this latest version, I'm running Windows 11, I've actually have the Winget update or upgrade commandlet in there. Can I get everyone to go to the Academy event page? For this exercise, we're actually going to be using malware. But the problem with that, I don't want you to infect your system. So we're going to do this in two stages. One, we're going to learn how to install Suricata in an environment that we used yesterday. Then we're going to stop at that point and go to the Academy Virtual Labs, which is a sandboxed environment. There's no outbound internet connection. And that's where the malware is kept, okay? So it's two parts. One is the installation. You're going to do that using the group server that you used yesterday. And the second part, which is this one here, using Suricata to analyze packet captures is where we'll move to the Academy. All the instructions that we go through installing is on the Academy, but has been done already for you. So just a revision for those people who don't remember the IP addresses for getting into the jump host. So you're going to SSH to APNIC at 202.125.97.4. And if you're jump host 3, remembering from, I think, this point forward, you would jump host 3. That point back, you would jump host 4. So you go to 43 at the front, 44 at the back. And my updates are interrupting. Once you're there, you type in the password training, and then from the menu, you will select your group number. Can I get everyone to do that now? So I'm going to go to jump host 4 and log in. And I'm going to go to group 30. So make sure you're able to get access to your server. Same group number as what you had yesterday. Just keeps it easy that way. If you weren't here yesterday, let me know and I will allocate a group number. Were you here yesterday? So, group 1. I didn't think about online. I didn't allocate numbers to people online. I thought everyone was face to face. So jump host 3, number 1, because that was broken yesterday. It was working this morning. Can I get you to open up the installation document? Starting from page 2 are the steps to install. So we're going to get a listing of the latest software. Then we're going to install some dependencies that we need. So we need the JSON query tool. We need the software properties common. And then a text editor if you want to use Nano. Otherwise, if you're experts at VI, you can use that. Just like Wireshark, we're then going to do add apt repo and the Suricata stable. To install Suricata, we use the install-y Suricata. And that's one of the easiest ways of doing it, is adding the repo rather than building it from source. Once it is installed, we're then going to install EveBox. And the way that we're going to do it is that we're going to download an installation file. And that's what this .deb is. It's a Debian installation file. And then we're going to install that Debian installation file. So that will get us to the bottom of page 4. Can I get everyone to get to that point? And then I'll start talking about how we set up Suricata and modify the configuration. of that. Once we get everything installed, we can start setting it up. I'm not going to specifically talk through the steps, but so I'm now at the point of just about to install my eBox, but take your time. Make sure you get Suricata installed, download eBox and get ready to run the installation package. So I might just start talking about what we're going to be doing now. So the first thing is that everything that we want to modify is in a YAML file under the etc Suricata directory, and it's called suricata.yaml. For those people who have ever edited a YAML file, you'll know how painful it can be if you don't get the spacing correct. So always, when you are modifying a configuration file, make a backup of that, like I talked about on Monday. So we do a backup, and then we're going to start looking at the update sources. So any intrusion detection system and firewall or antivirus system is only as good as its latest update. So if you haven't updated a firewall rule set, then you're not going to be protecting your network very well with the latest ones. And so that's what we're going to do here, is we're going to get a listing of where Suricata gets its updates from. So we scroll down and it's going to show us a whole heap of different update sources. Some of these are paid versions of updates, some are open source and free for you to use, and you can add custom update sources. We then use different tools to just pull out the name. So here we've got the ET Open, and this is the community rule set, Emerging Threats Open rule set. And we've got Pro, this is where you pay for a rule set. And there's a few others. I then get you to go and add the update source. So we're going to enable the traffic ID, the threat hunting source, and then the traffic, if it's encrypted, it's going to be using SSL and some sort of certificate. A very smart network engineer in Salesforce discovered that there's a way of identifying unique traffic to a system based on that certificate, the IP address, and the header information or the user agent string. And so he basically creates a hash value of that, and he's created a listing of known hash values, which is referred to as a JAR3 fingerprint. So I will show that to you later on when we're doing the investigation. But essentially, SSL blacklist or blocklist / JAR3 fingerprints, we want to enable that as well. So that way we can also look at bad encrypted traffic. And then once we've done that, we look at what is enabled, and we should end up with these 4 items. So the community list, the threat hunting list, the encrypted traffic list, and the identification for the types of traffic that you've got. Once we've done that, we do the Suricata update. So basically, we're looking at the lists that are available for us to use to update our rule sets. We then add some lists to this update source, and then we update Suricata. Can I get everyone to do that now? And we'll stop at part 2. So I'll do it up the front if you want to watch along. So the first thing is that we want to copy the software. The config file, so etc suricata.yaml, and we want to copy it to a backup. We haven't started modifying that just yet, and we're going to then use the Suricata update tool and we can see that we've got a whole heap of information, and it's got information related to how old that information is. So example, this one here, the Stamus phishing one, these are new. So we've got the last 30 days of phishing domains, last 14 days of phishing domains. And there's a whole heap of commercial ones here. So if I scroll up, so there's a whole gambit of them. So ET Open, we've got an aggressive blocking list, Windows malware, commodity, traffic ID rule set. So there's a whole heap that you can enable. If we just want to get the names, we can do a grep for the fields of names. So you can see here, there's quite a few of them. We're just going to enable the open one, the traffic ID one, the threat hunting one, and the SSL JAR3 fingerprints. So we do the sudo Suricata update, enable source, and then we just highlight and paste the source that we want. Arrow up, and you rinse and repeat. By default, the free commercial version, the ET Open, should already be enabled. That's why we're not enabling it. Doesn't matter where you are now. The downloads folder was just to download that install file. Suricata update enable. I spelled something wrong. I spelled something wrong there. Just got to move my window to see what that full error message is. So they've done a change to the Suricata install. Valid choice, list enabled sources, choose from list sources, list enabled. So I've got a no D there now, so they've changed it. So in my lab guide, I don't have a D, so if we do a D, that will fix it. So I've got those 4 sources available. So now when I do an update, it's going to go and check each one of those locations and start downloading the rule files from those locations and combining them. And so we're going to see here, it's loading nearly 50,000 rules. Then it's going to try and test that. And so what it's done is it's put it into this var lib suricata rules, suricata.rule directory. There's nearly 50,000 rules, 38,000 nearly are enabled, and 0 have been removed, 0 have been modified because I've done no changes. It's a fresh install. So that's a lot of protection in a few minutes. And hopefully when it does the test, comes back as done. So I'll wait for everyone to get to that point. Jump host 3, 1. Did you SSH into APNIC?
Yeah.
192.168.30.10,
Yeah.
43? 44. No, it should be 43. Jump host 1. No, you're in APNIC host 1, so jump out of that. You're in the, you're in the virtual machine. Okay, all this part we're doing is we're installing on a different system. So you should be, yeah. So you should not be in the academy at this point because the academy doesn't have internet connection. So you should be using the system that we used yesterday afternoon. Yeah. Only 3, because I know they're free at the moment. We don't have to pay for them.
Oh, these only 3 years.
Yeah, we can go through more. So what you can do is if you have a look, run the, I'll just arrow up without the grep. No, what it is the,
Commercial.
yeah, under the license, it's got MIT and then license is commercial. So the commercial is usually you've got to pay for.
These are the people to be downloaded and we can't do any configuration like that. Is it?
You can download it.
Can't.
Actually, you usually need an API key to be able to download it. So depending on the license and how they've set it up. Okay. So Tuan? This is what you need to do is SSH to there using that password, but replace the X with number 3. Making sure you're not in the academy. Group 1? Okay. Now, I had a question in regards to our list. Why are we just choosing those 4? One of the main reasons is if I go have a look at our list, anywhere where the license is commercial, you have to pay for that. And so I've chosen 4 lists that are free and will probably give you the best detection for free. There's a lot other options there and you're welcome to experiment with that. But for our lab, I know that those 4 items that I chose should detect the malware that we're analyzing. Okay? But as I've already alluded to, is that it's a game of fine-tuning. If I'm going to enable 100,000 rules, what sort of impact is that going to have on your traffic? Because it's got to go through each bit packet and each rule until it may or may not detect something. So if you're doing an inline intrusion prevention system, it might slow down your system, and then you get end users complaining, hey, it's so slow, I can't do anything, because you add latency to the network traffic. Intrusion detection system's different, but you might overrun your Suricata box and it doesn't have the processing power to do all that processing of the packets and the rules. So you now are missing alerts. So you need to think about that. What are you enabling and why you're enabling it? There is no right or wrong answer. It's just a fine-tuned version for your network. How's everyone going? Have we been able to get our Suricata updated? Is everyone at that point? So now we can potentially jump over to the Academy because we've installed the software that we need. Everything else we can do on the Academy because we're not downloading anything. But if you want to follow along here, what we're first going to do is that usually when you install an intrusion detection system, how do you tell it which is the LAN side or your network and which is the bad or the WAN side of your network? Did we do that when we installed Suricata? No. When we install Snort, it actually asks you what is your IP address range that you want to monitor. Suricata didn't do that. So in that configuration file, remember the rule set that I showed you where there was that variable name HomeNet in my rule set for Snort? Suricata has a variable as well. So we're going to do a search for the home network to see what that IP address is that's been added there. So first up, I'm just going to do a WC on that file. And you can see that this configuration file has got nearly 2,200 lines of information in there. So that's a lot of configuration to do. Doing a grep -n, -n means show me the line number where you find this string. And so here we can see from line 18 to line 39 various references to HomeNet. Anything with a hash at the start is a comment, so it's not actually a real variable at this point. But we can see here that it's using the private IP address range for IPv4 at this point. Can everyone see that? Yeah? So if you're not using a private IP address range or an address range that's not in there, then it's going to be useless. So you would need to update that field. If you're only using a subset of these, I would then only put in that subset. So if you're only using 1/24 IPv4 network, 192.168.30.0/24, that's all I would put in there. That way it's not listening for IP addresses that aren't in your control. Does that make sense? I can also break it out into individual ones. So instead of doing one or more, I can just do an individual one. So comment that out, enable one of these. In regards to the other ones, you can also break it out to be a web server farm. You can break it out to be a mail server or Telnet or DNS or something. And so you'll be able to either use the same network range or put in your own network range. For my external net, all I've done is an exclamation mark at the front. And if you're a programmer, usually the exclamation mark means not. So anything not home net. Does everyone understand that? So that would be one of the first things that you would need to modify. By default, when we did the update, it said that it's going to put it into this rule path location when we do the install. But did we see where that, inside this file is where you can modify where you store the rules. Now, we did our update and it said it was going to install it. I don't know if I've kept it on the screen, but we'll go have a look. Yeah. For jump host 4. I don't think so. Yeah, 29. Okay. I did ask earlier if anyone had a jump host. Didn't have a jump host, but that's okay. So here we can see that the rules are being stored in var lib suricata rules suricata.rule. So in my suricata YAML file, I need to make sure it's referencing that directory to be able to pick up those new rules. So let's go have a look. Oh, wrong file. And so what we can see here, the default rule path is var lib suricata rules, tick. So it matches what our update did. And then in particular, this file I want to use. Any other files, I just indent it, dash, and the name of the file. As long as it's in that same location, I can add my own custom file sets if I want. That way, when you do another update, it doesn't override your changes. The other configuration setting to change is we've mentioned which IP addresses to monitor. We've mentioned where to get the rule set from. But if I do an IP-BR address show, I haven't mentioned which interface to look on. At this point, I've only got one interface, but if I had 10 network cards for this box, I need to specify which interface it should be listening on. One or more interfaces, and so on. So that it would be the next thing that we need to change. Now look at the line numbers. So I've found how to get you just to that point. Otherwise, you're going to have to do a less the file name and scroll through until you find it. So that's our next part, is to look at the interface that we want to listen to, and that's referred to as AF packet, address family packet. And what we've got, it's listening on interface E0, which matches my interface up here. I've only got one, so. Now this one I'll explain probably later on, but essentially, Suricata has the capability to look at a packet capture and try and extract files from that packet capture. And the way that it does that, it uses a variable called file store. And that is either turned on or turned off. And then you need to add some extra information to it. And at this point, it is not enabled. We will enable it later on. I don't like using Suricata for that because the way that it extracts it, it gives it a random name. I don't like that, whereas I like to keep the original name. So I use other tools to extract. So what we can do is go and have a look at our rule set to see what the rules look like. So if we go to our directory where they're kept, so var lib Suricata rules. Oh, that's annoying. I'll just use the sudo command then. Doing a sudo ls, we get the rules and we get the classification. Very similar to what I mentioned with Snort. It has that classification option. If we want to have a look at how big that file is, we can do it wc-l. And it should match what we saw as an update, 49,500 or so. And then we can actually look at the contents using the head command. And I'm just going to look at the first two lines. So that's why I've done a -n2. And we can see here, it looks very similar to the Snort rule creation. So I've got the alert IP any, alert IP any, and then it's got flow established, app layer event, flow in app layer anomaly. Yeah, not a very good one to look at. One of the first malwares that we're going to look at is an older malware called WannaCry. Has everyone heard of WannaCry? It'd be unusual if you haven't heard of that ransomware. It basically encrypts your hard drive, asks for Bitcoin to unencrypt. Very popular. So what we can do is that we can use the grep command to search for occurrences of keywords in this rule set. I'm going to do a -I because I don't care if it's case, whether it's uppercase or lowercase. And then I'm just going to see how many occurrences there are. And so in this 49,000 file, there's 10 alerts for the WannaCry. And this is something that you might do when you update your rule set and you're looking to make sure that you're protected from the latest malware. You might go searching for that malware name in the rule set to see if they've actually got one at that point, rather than just hoping, oh, I've just done the latest update, it's going to be protect me. What we can also do is we can use the -N at the front of it, and it's now going to tell me where in the file that alert is coming from. So line 30,454. So if you know you're getting attacked lots and lots, you can do a fine tune by moving that rule set further up the tree. So that way it alerts on it sooner, rather than having to go through 30,000 first. But you can see this one is quite complex. Could you imagine writing your own rule set with that? If you do reverse engineering, malware analysis, you might be able to. I wouldn't be able to. I'm too lazy. And I've come from a Cisco reseller background, so I'll sell you a solution, make money out of it. The other file to look at is the classification.config file. So I'm just going to bring up the first two lines there, but it's very similar to what we saw in the Suricata. So it's a short name, a description, and then the priority, 1 through to 4, 1 being high, 4 being low. There's not very many classifications, but you can add in your own classifications. There's 43 classifications in that file. And you don't really need to type this one in, but if you're interested, what this does is read that file and then tries to find out how many are set at priority 1 through to priority 4. So we get to this point here. So in that classification, there's 15 of them that are set as priority 1, 20 is 2, 7, and 1. So everything that we just did there, I went through it a little bit quickly. You can do it again on the Academy Lab, apart from the installation part of things. So can I get you to shut down this lab? And what you're going to do is go to the event page, and we're now going to start up the lab. Just going to log in off screen. Yep, start the same lab. So if you've opened up that link from the Academy events page, it should take you to this virtual machine, virtual lab. Use Suricata to analyze packet captures. So we're going to click on launch and we go yes. So we've gone through and we've installed the Suricata, and we're now at this point here where we're going to be starting the virtual machine. So I'm waiting for that to start in the background. What we're going to be doing is we're going to start looking at some packet captures. These have already been downloaded and put onto the virtual lab environment. They are available for you to download if you want, but do it at your own risk. It's a zip file with a password on it, I think, from memory, but I don't remember what the password is, so maybe you'll need to brute force it. But a lot of the material or some of the packet captures, there's a great website called www.malware-traffic-analysis.net. And they've got lots of sample packet captures with malware in them. So you can learn how to do the analysis if you want, or reverse engineering the malware. A lot of the more malicious ones, they will have some sort of password on there, but if you go to the website, it will explain how to do it. They also have some walkthroughs about how to investigate if you want. But essentially what this person has done is they've created a Windows domain sandbox environment. And on one of those machines, they ran the malware. And then they were listening to the network traffic. So they were able to capture that network traffic to see what was happening. So that's what we're going to be playing with. So a bit of a hint already. Here are some IP addresses. Here are the MAC addresses, the type of operating systems they were running, and what they were doing. So two were domain joined to these controllers, and then one of them had the WannaCry launched on it. So what we're going to do is once Suricata starts up, we'll go into the directory, workshop, lab 1, and we're going to replay this packet capture using Suricata and see what we get from it. To replay the packet capture, we use the -r command, just like what we did yesterday when we used T-Shark. So sudo suricata -r, the actual name of the packet capture, and then you can set up a custom directory for where you want the logs to be stored. So we're going to use lab 1 logs subfolder. So we're just doing -l logs. By default, it would go into var logs if you do it. And then we're not doing any checking or checksum checking on that. So we're just going to say -k, none. What happens in the background, behind the scenes? Suricata is going to start up and read information from the YAML file. In that YAML file, it's got details about where to find the rule sets, what interfaces to listen on, and then the gone blank. IP addresses that are your local area network that you're going to use. If we're not particularly worried about that, we don't need to change anything, or if this is part of that, so going back to here, are these addresses in our home net? Are they in our home net? when we looked at the configuration file. It was the private IP address ranges, weren't they? They were the 192.168/16, the 172.16/16, the 10.0.0.0, I think it was /16 or /8. So yes, they are. So I don't need to change the IP address. Our interface is set correctly, but we're not telling it to use a particular interface. So that's okay. So once it knows where to get the rule sets from, it's going to read those rules. We're going to replay the WannaCry, and it's going to match it, each packet, to the rule set. And then anything that it finds, it's going to put it into this logs directory that we created. If we wanted to, we could tell it to monitor an interface using the -i, but we're not going to worry about that at this point. Once it has finished replaying the file, it's going to create in that logs directory 4 files. It's going to have the Eve JSON file, fast.log, statistics about the packet capture, and the Suricata log file if any errors occurred and what it was doing in the background. The 2 files that we would be mainly interested in is the eve.json or the fast.log. So that's what we're going to do, is go and read that information. So hopefully my lab has started up. Clicking on next, it talks you through the installation. We've done all this just then on that jump host that we used. So because we're not connected to the internet, you can't complete that. And if I scroll down, most of them have been ticked already. So if you scroll down to the point where there's no ticks, and then it talks you through that process of looking at the configuration file. We're going to go to the next page, and this is where we're looking at Lab 1, reviewing that WannaCry malware. So what we're going to do is open up a terminal and connect to our Suricata server. So I'm going to SSH to the Suricata server. Password is training or lowercase, and we should see that my prompt has changed to Suricata. We're going to change into the Lab 1 directory, and inside this directory, we have a logs folder already created, and we've got the pcat file that we want to replay. So we're going to use the sudo suricata -r, type in 20 and press tab, -l for logs, -k for none, and then we press enter. Password is training or lowercase, and now it's going to start running in user mode and looking at that packet capture. Sorry? Yeah, the -L and -k, what about it? That meaning is this. you're modifying the default log directory. Instead of going to var log suricata, we're putting it inside the subdirectory called logs. And we're saying don't do a checksum on the packet capture. So in this case here, that packet capture has 46,000 or over 46,000 packets in there. Imagine if we were analysing that yesterday. We'd have to play around with it for a while, but also if you have a look at this, the size of that packet capture is 37 meg. So the bigger your packet capture is, the less likely you're going to be able to open it up in Wireshark. That's another reason to use T-Shark and other tools to do the analysis, because it can do a stream of the packets, whereas Wireshark has to load it all up into memory and it can crash Wireshark. Now, you asked about what is the -L and -K. In the lab guide, I've got a little hint for you. So you can use it to go get the help and then find what that means. So I've said offline log checksum. It's gone and shown you -R means this, -L means this, -K means this. This little hint here. So now that we've got the packet capture run through the suricata rule set, we get these 4 files created. Now we've gone from 37 megs in size to these 2 files. Eve.json is exactly the same as fast.log, it's just in JSON format. And so we've gone from 37 meg down to 1.7 meg in size. So you could potentially use this as a way to reduce your storage capacity. Disadvantage though is if you delete the original packet capture, you can't go back to the source. Let's have a look at this fast.log file. So using the less command, we're going to go to the logs directory, fast.log, and it's going to start showing me some information. So it's in a completely different format to what a packet capture has. So looking here, we get our timestamp, we get the revision, the ID of what it is, the message, suricata ICMP v6 invalid checksum, and then the classification, the priority of 3, what the protocol was, the source IPv6 address, and the destination IPv6 address. So there seems to be a lot of IPv6 ICMP traffic, and if I just keep hitting the space bar, it's going to keep paging down. And eventually, you're going to see a different alert. So this one is ET exploit possible eternal blue probe. And then the Microsoft alert number. What the source IP address is, what the destination IP address is. So we've got 149 going to 143. If we go back to our slide deck, this is where it was executed, which was 149. it's now executed, and as part of that malware, it scans for other network connections to infect. So it's trying to get into 143, which is the domain controller. And we can see that with this alert, 149 scanning 143, 149, 143, and so on. Now we've got a response back from 143 trying to scan back to 149. So maybe it's now infected 143. Going down a bit further, we're now seeing this attempted administrator privilege. Still more options there. And this is the behavior of what the WannaCry does. So the indicator of compromise. I press Q to jump out of there. And what I can do is I can say, let's do a search for the keyword exploit in that file. And that's just going to pull out all of the lines where the word exploit is. If we wanted to, we can have a look at how many lines were in that file. So there's 8,000 alerts, just under 8,000. Whereas if we just look for the keyword exploit, it's just under 7,000 or just over 7,800. So most of them are alerts. But it's taken that packet capture that had over 46,000 packets in it and condensed it down to so many alerts. What we can also do is that we can use the JQ command. So let's go into the logs directory. We're going to get the latency occurring. And it's essentially the same as the fast.log file, but it's laid out in a nice format for you. Compared to what we saw in fast.log, this one's easier to read. It gives you a key and then a value for that key. So we can see source IP, destination IP, protocol, ICMP type, action, allowed, Suricata, alert. Using the jQuery tool, we can actually cut out different parts of that alert quite easily. So using JQ-H, it's going to tell you about different things, but essentially it uses a semi-SQL type language where you can do a select on the file and only pull out certain information. So I'm going to do a select for anything that has an alert severity. So looking here, what I'm saying is dot is the very beginning, alert, dot, severity, and then I can pull out that value. So anything that is high priority, I want to be aware of. So 3 is not that big an issue, but 1, I need to find what that is. So that's where I'm now pulling out just those alerts that have an alert severity of 1. So we can see here that this is the flow ID, the packet capture count, so packet 1161, Eternal Blue probe, network Trojan was detected, affected product was one of these operating systems. Once we've now pulled out the alerts that are 1, we can also select just the source and destination IP. So we can now start pulling out which machines have been impacted and how we're going to look at that. So now we're going to use this command here, and it puts it in a nice format. So it's grabbed the source IP, the destination IP, and the alert that was raised because of that. Instead of piping that to the less command, if I do it to the word count -L, it's still going to give me a lot. So this is quite a bad packet capture. We know really why. So it's going to give us the source and destination address. So that's still a lot of files to go through, or a lot of information. So what we can do is we can do the sort unique option, and then we can get the top talkers at the top. So we can see at the top here, now we've got nearly 1,300 pulsar beacon responses, the double pulsar, going from 138 to 172, 149, and back again. Then we have only a few alerts for the Eternal Blue for the different addresses there. So it's taken those 7,800 alerts and it's now compressed it down to 36, which is more manageable to handle for your investigation, rather than you having to manually go through and look at each one. So once you replay a packet capture, you go into the logs directory and you use the fast.log, or you use the eve.json file to pull out the information or to see what the alerts are. And there's various ways to do it. So we've used the cat eve.json, passed it to the jQuery without any sort of query, less to do it one at a time. Or we can do the JQ select query, in this case, looking for the alert or looking for SMB. So now that you've got these alerts, you can start thinking about, from an incident response point of view, what's happening. So we want to find out things like who is attacking who. What time did it occur? Was there anything else that was strange happening? And then what was the vulnerability? In this case, it was the Eternal Blue, and we had a Microsoft alert related to that, the vulnerability MS17- I can't remember off the top of my head. But the idea is that you should build up this timeline and an analysis of the attack or the malware incident. And we can see that when we look back here, we can see which IPs are attacking which. But remember, we can see that the 149 was the one that we detonated the malware on. And then it started scanning the domain server. Now the domain server started scanning other systems. But not only that, there's another payload that was brought down, which is that double pulsar beaconing probe. So C, command and control server. How's everyone going with that? You got that done? If I'm going too fast, let me know. If I'm going too slow, let me know. And if you don't understand, ask. For those that are interested, these were the alerts summary of what we got. But we could see that in the lab anyway. And if we go to the actual Suricata rule set, these are some of those rule sets that so we can do a grep and we get this rule set coming back that picks it up. So this is the vulnerability that we could go research, MS17-010. So based on that, an intrusion detection system helps you provide context to a packet capture. It uses the rule set to basically identify on a signature malicious or bad traffic. That malicious or bad traffic is then going to give you source addresses, destination addresses, and potentially what the malicious behavior is. However, Suricata needs to see that traffic. You can either have it inspecting traffic live off the wire, so doing a mirror to it, or you can replay packet captures. I know a lot of smaller networks, they tend to do capturing of the packets, and then another system is used for the analysis. So that's not real time. Whereas if it's seeing the traffic off the wire, that's real time. But it comes back to what is your security posture and what you're trying to achieve. Looking at Suricata, how is that different to T-Shark, TCP dump, and Wireshark? It detects it, whereas you need to have the knowledge to be able to say that packet looks malicious in T-Shark, or you need to have that knowledge to know that in Wireshark or TCP dump that that's malicious. True? And yesterday we did a very manual process of going through packets and investigating things, so we need a lot more skill. Did you need any skills for this? No, you just need to know about the -R to replay a packet capture, and it created the log. Really? So once it was installed and configured and had rule sets, it created this massive alerts for you. Okay? I was surprised no one said, Wireshark's got a GUI. Suricata doesn't. So a lot of people like to use GUIs for some reason. So that's going to be what we do in the next lab. So lab 2, we're going to analyze some other traffic, but we're going to use EveBox to read that JSON file. Any questions? So one thing to be aware of, you do need to keep Suricata up to date to get alerted about the latest threats. If you don't keep it up to date, it's not going to be able to tell you about those latest threats. And that's where some people go wrong. They install it and they forget it. They never update it. And then they wonder why it's not alerting. Some people, if you're lazy, they will buy a commercial rule set because then it keeps up to date and they don't have to write rule sets. Or they buy a commercial contract where they will help you write rule sets. It's up to you how you do that. We've talked about how to do that already. and how to update it. And you can also schedule it for a cron tab to update on your behalf. Remembering that if you're doing any modified rules, how that is managed. So we're going to have a look at another malware called Dridex. Does anyone know what Dridex is? You've heard of WannaCry, but not very many people have heard of Dridex. Dridex is a malware that tries to steal banking credentials. So once it infects a laptop or a system, it listens for any sort of connection to certain banking websites. So it's quite easy to go get a listing of a country's most popular banks. And so this person, actually Dridex is a very wonderful ransomware in that case, because it does this massive analysis of different websites and then it injects malicious traffic to do the credential grabbing from that banking website. And then it passes those credentials onto the real banking website and then emails your credentials to someone else. So that's how they steal bank login details. So the same sort of process as we did in the first lab, we're going to replay it into the customs logs directory, no checksum, and we're basically going to be using EveBox to pass it this time. So it's a little bit different. Again, it's been downloaded from this website here if you want to get access to it. So let's go and have some fun. So we need to change into our Lab 2 directory. Inside this Lab 2 directory, oops, if I list this up, we've got a few extra things in here. We probably won't use those at this point. We might actually. So we've got our PCAP file. It's not very big. 3.2 meg, about that. And then we've got some extra files here, and these are for fingerprinting encrypted traffic. Because remember, banking websites, they're not going to be on clear text, are they? They're not going to use HTTP, they're going to use HTTPS, so it's going to be using encrypted traffic. We've got our logs directory, and then essentially we just want to replay that file. So we do sudo -r, the name of the file, so 2019 -l logs directory -k none. If I've typed it in right, it's going to go and do that for me. If you click on next, it will take you to the next lab, by the way. So it's now completed. Inside the logs directory, we should see that we've got those 4 files still. They're not very big at this point. One's about 60 kilobytes, the other one's about 4 kilobytes. And in this case here, it tells me that that packet capture, it processed 1 file and it had 3,683 packets. So it's nowhere near as big as what we had in the previous lab. So what we're going to do now, instead of using the jQuery tool to go and do the analysis on the fast.log or the eve.json file, we're going to run EveBox, which is a web server that will interpret JSON files and then display it in a nice format. It's specifically built to help with the Suricata type files. So to run that, we go sudo evbox, and we're going to then use, because there's a bit of latency, I'm going to use the typing here. Oh no, that's got latency as well. So let's see if we can fix that. So what I'm saying here is use evbox to open up the one-shot website server. No open, as in don't keep it listening. I want you to listen on this IP address, 192.168.30.1, and I want you to read this file for me. When I press enter, this is now going to bring up that web server, and it's going to then give me a web address at the end showing to get to this information, I go to http 192.168.30.1 on port 5636. So I need a web browser to do that. So I'm just going to click here, up in the top left-hand corner. I might think I've got a So I've got a DNS entry for Suricata to match to that address, 192.168.30.1. And we're now in that web server. But I've got no events found. Why is that? We know the file's got 60K in size, so there are some events in it. Didn't hear what you said.
Before, after 24 hours.
Correct. So it's the timeline. Have a look up in the filter setting up the very top. So a lot of scenes, they will try and filter based on the last 24 hours, last 7 days, whereas the timestamp for this packet capture was 2019. So we're not going to see it with that filter. So we go from the drop down and we change that to all. Now we are seeing everything. See the timestamp from 5 years ago, 2019. That's why it wasn't being filtered. Sorry, it wasn't being displayed. There's a black arrow here. If we click on that, that's going to give us more information about that alert. And it uses the color code. So red is usually a bad sign. When we click on that, it shows me the timestamp, what the source IP and port number is, the destination IP and port number, the signature that alerted on that, the signature ID, and the severity of 1. Now this is encrypted traffic, and so using the jar-free information, if I scroll down, it's actually created a fingerprint of this information. And the fingerprint is usually a build-up of the information here and the IP addresses. And this is the raw alert in JSON format that this is reading. So it lays it out in a nice format for you. In the TLS section, can anyone tell me what version of TLS is being run? 1.2. You can add a tick here and check. What is the source IP? Looking at this alert, you should be able to get the source IP. Yep, so 72, 205, 170, 179. What's the source port? And so these are all things that you would add to your ticketing system when you're doing an investigation. Because if that's your system that's compromised, you would need to go check whether you need to do a reinstall or something. I'm not going to type in the value of the fingerprint, but there is the value there. And what is the CN subject name? So you've got AF, Y, G, R, U, D, E, D, E, D, and so on. What's that? It is a long one. So with EveBox, what it's done, it's taken the JSON alert that we get normally, and it's now displayed it in a web interface that is a lot easier for you to use. The signature that was alerted based on that looks like this. We've got the alert, TLS is the protocol from the external network to our home network, and then it's looking for a pattern of some sort. And we can see a hex value for the pattern that it's trying to get to. In particular, it's looking for established from the server content 16, content 0B within 8 and byte test of 3. If you are wanting to learn more about rules when they're complex like this, a suggestion is if you've got a free account to any large language model, you could potentially copy that, paste it in and say, tell me what this is doing. I haven't tested it. I only just thought about that option, so let me know if it works. But it might break it down for you. But it is very complex, and there are some smart people out there that spend days or weeks writing these alerts, these signatures. But essentially, what it's trying to do is use the encrypted communication, but a fingerprint of that encrypted communication. So it combines all those TLS parameters that I asked you to have a look at, say the version, the algorithms it supports, the common name, and then creates an MD5 hash of that. And then based on that, we can then learn whether it's safe or not. And there's JAR3 for the client, JAR3S for the server. And you can go and read more about that. We'll do this a bit later on, but we can run the JAR3. But here's an example. It's got the destination IP, the destination port, and then it brings out a fingerprint and a digest of that based on that information. So that will start adding it to our Suricata. And this is the type, this is out of the Wireshark interface. If we go have a look at the secure socket layer, there's all of this freely available information that helps us to create that fingerprint. So it uses the version, the cipher, SSL extensions, and then converts it all into a string, and from the string it creates a MD5 hash. From a protocol analysis, Suricata is smart enough to realise its web traffic without it having to be on port 80 or port 443. So we could maybe set it to a completely different one. So SSH could be on port 1337. To find out all the supported protocols that it can find, go to this web URL here. And if it's encrypted, it's going to use some sort of signature rather than the contents of the packet. It's going to look at other information there. And we can also expand it out to support SSH information as well, using the HASSH format. So I think it's lunchtime. So let's have a break there and we'll come back. My suggestion is that you save your lab for the next 50 minutes or so, rather than let it keep ticking down. So let's go back. Save your lab. And after the lab, after the lunch, we'll look at lab 3. So what we're going to have to do is update a few things before we can run it. The first thing is that the Honeypot network is using this IP address. That IP address is not in our home net. So we're going to have to add that to that home net variable. You can use your text editor to do that, but what I've got in the lab is just a search and replace. I get it to search for this string here, and it replaces that string and adds this at the back of it. Then we run the replay of the packet capture. We go into the logs directory and we essentially run the Eve box to have a look at the capture. So for our lab 3, we're going to add this IP address range to our home network. We're then going to run the replay of the cowrie.pcap file, and we open up Eve box. So that's our first part to do. And then we'll start looking at what information we see in this capture. So I'm just going to flick back over to my terminal window and I click on, or I type in Control-C to break out of the running Eve box. If you click on Next, it's going to show what we're planning to do. And I'm going to change into my Lab 3. The latency is very high. Even the latency is so high, the cutting of information. Don't even know what happened there. I'm going to, if the latency gets too high, you can try and just type in from the clipboard. So CD got there eventually. So if your latency gets too high, I forgot to change the data center. So an option is to end the lab and go and change to the European data center, maybe, to see if that helps with that. So what I need to do is to update the Suricata setup. So if we have a look at suricata.yaml file, what I'm doing is I'm searching for the end of the home net setting, and I'm going to use a tool called Search and Replace, or SED. So I click on that, and I'm going to fix up my SED. This is going to be the hard. Oh, I didn't get any problems because I'm typing in a password. If I got characters repeating, it might come up as a bad password, but that looked like it worked. So now if I do a check, I should see I've now got at the end of that string the updated honeypot IP address. Because we've done a change to the configuration file, we're going to have to restart our Suricata. And then waiting a short time, I'm going to check the status that Suricata ran without an issue inside the config file. And we can see here, active running. I hit Q to get out of the status, and now we can start running the replay of that. So sudo space -r, Suricata space -k for none, -l for logs. Now the only thing I should point out is that if we have a look here, we don't have the custom folder where we're going to store the log files. If I go to run Suricata and I'm telling it to use a custom log file, I replay that, I'm going to get an error because it doesn't exist. It doesn't create the log file. You need to create that first. Now that I've created that log folder, it should be able to run for me. So what this one has done now is it's replayed the one file with 101,000 packets. So it's a lot bigger. and it's created the eve.json file and the fast.log file, just as previous. And the cowrie.pcat file is 11 meg in size. So using EveBox, we're going to tell it to run that Eve JSON file, and we're going back to our Firefox installation, and we're going to do a refresh. Not on the event, but I just click on EveBox here. That will take me back to the beginning. If you shut down Firefox, just open it up again, go to Suricata 5656, change your filter to show all events. That doesn't look right. No, the other one's not running. I just need to refresh. It was cached. So make sure if it doesn't look right and still talking about Dridex, click on refresh to tell it to go read the file again. So what you now get is a whole heap of other alerts. So you've got red being bad, yellow's a bit of a warning, blue's not too bad, nothing to worry about really, it's just an invalid packet. From the events tab, shouldn't have clicked on events there, I want it to go back. From the events drop down, if I can get it on the right location, I can now focus on a particular protocol. So if I'm interested in finding out about SSH, I can scroll down and select that, and it will show me alerts to do with SSH. And visually, if I start scrolling down, I'm not getting any red colored alerts. A lot of them are just green, and it's just showing you that there are SSH traffic occurring. Using the back button, I can go back and we can see here that we've got this red alert. If I click on that red alert, it shows me that it's to do with a MirrorBot login attempt. So MirrorBot or MirrorBot, it is a type of malware that has a whole listing of default credentials for various vendor equipment and Internet of Things. And what it does, it basically scans the internet, finds an IP address, tries to log into that system, install itself, and then adds it to a botnet. And then it moves on to that, then becomes another device to start scanning for other devices to install that software. And then eventually what will happen is you'll have this command and control center with all these botnet devices that can be used for a DDoS attack. So for this honeypot, it's detected this software or this IP address is trying to obviously log in using SSH or Telnet and install this MirrorBot software. Now I've got in here, what is the signature ID? You can do 202 3439. Hopefully that's the right one. And that's correct. If we click on that signature ID, it's going to now give me a listing of all alerts related to that. And actually, by clicking on that link, it puts in the filter box alert.signature_ID:2023-439. So instead of you having to, at the command line, know how to create your query using jQuery, it does it for you in this e-box. Has anyone heard of the website called VirusTotal? Yeah. So VirusTotal, it is a paid for service, but it also offers free information. If you find something that is suspicious or an indicator of compromise, you can use that website to see if it is a malicious IP address, malicious file, or something like that. The recommendation, though, is if you're going to try and upload something to it, don't upload the file itself. Do a hash value and then paste that in. So I've got a link here that takes you to VirusTotal, and I've already put in the IP address for 203.202.246.47. So this source IP that we've got here. I'm just going to say open in a new window. And remembering this might be a little old, but what it's going to show is that it was found to be malicious in 2018, 1 detections, and it was for this domain here, ddns.net, and communicating files from that domain was 51 using the Win32.exe file, but in particular, the name of the file was hi.exe. So sometimes the malicious actors will try and compromise someone's website or someone's public server to upload files to, and then when they compromise another system, it downloads those files from your compromised server. So that way it's a way of them hiding their footsteps, but also it means that once that server gets detected, it gets on the blacklist. So it doesn't affect the malicious person's infrastructure. It affects that businesses who's had their server compromised. So we can see that that's what's happening with that. Currently, at the moment, it's got nothing, so it's green. So it's been cleaned up in theory. There's another website that is very similar called DShields, and so you can also do a look up on that. And it looks like, because we're all coming from this location, it's put a rate limiting on it, but it's located in Bangladesh, it's for this network, and there's no reports. So this is using the Internet Storm Center's database to check. But in 2018, it was seen as honeypot logs. If we want to do a custom alert, we can still use that alert.signature ID, and as long as we know what the number is, 2027973 and click on search, we're now going to get other information. Now, this one is in relation to a similar MirrorBot exploit, but it's using Telnet instead. And it's attacking a digital video recorder, usually for a closed circuit TV. And so we can see it's trying to get in from this IP address, this IP address, this IP address, and so on. And the same sort of process as before. You scroll down, you look at an IP address, that is an indicator of compromise or an indicator of what could be a malicious IP. So you go use a third-party tool like VirusTotal to get a reputation status of that IP. And based on recent activity, it is still malicious. So malware URL. Based in Sweden, by looks of that, last analysed 5 months ago. You could go to details, relations, or community, because sometimes the vendors have not discovered it as being malicious, but someone in the community has. So you go to details, it tells you about what's there. Relations shows you different information there, and then any extra comments from the community. You can use other ones as well, yeah. Yeah. So any of the source IPs here, you could then go to VirusTotal, type it in, and check the reputation of that. And then if it is a known bad IP, you would add that to your block list on your firewall, maybe. Or you would set up an alert to see if there's any other devices on your network communicating with that IP address. So with that, honeypot packet capture, honeypot is a deception technology, and we'll talk about it in more detail tomorrow. And that deception technology is used to try and trick malicious people to log in. Once they've logged in, they're going to start trying to compromise that system. So you will be able to watch what they're doing to see the commands they use, the files they download, the IP addresses that they're contacting. And so these are all ways of getting intelligence about that type of attack that's happening. It's very much like if a burglar, a robber, wanted to get into this room, what was their way of doing it? Do they come up the back way here, try and break the window and come through a window? Or do they try and unlock the door there and come in that way? And the police will get an idea of what this particular person does, and they might do it for every type of robbery they do. So every house, they go to the back window, break the back window, and climb through the window. So that's called a modus operandi. So once we find a IP address, we then use some sort of threat intelligence system to determine whether it is suspicious, and we looked at that for those IP addresses there. Making sure that your network configuration is correct before you replay the packet capture. So it includes the IP address that you want to listen for. And then it gives you some context about what the traffic is, what it looks like. And in this case, it's told me here about the Linux Mira login attempt. So I could use those keywords to go off and do a search on the internet to learn about what are the indicators of compromise. And the same for this one here, default telnet root password inbound. Looks like something is trying to use that default passwords, and I've mentioned that MirrorBot does that, so it could be exactly the same thing. The alert that is used to flag on that last one looks like this. So what it's saying is it's doing from the external network to Telnet port on my home network, a fast pattern match, and it then is referencing GitHub. So you could go to that website and read more about what they're doing to be able to do that. But essentially, it's looking for information about the, no, that's extra information. It's looking for this, XC3511 as the content. Whereas everything here, this is something adding metadata. So it doesn't affect the rule. It just gives more information about that. And it's good practice to have. Any questions about that? Have I put you to sleep? Will this make your job a little bit easier? Maybe. Now, during the lunch break, I had a question from someone asking about what about the hardware to run this? The hardware to run it, I can't give you an exact option for that. I can give you generics, and if you go and have a look at the Friendly Neighborhood search engine and do a search for Suricata minimum hardware, in 2022, they suggested an 18-core Intel server, 128 gigs of RAM, fast drives to be able to store the packet capture. That should be able to handle 10 gigs of traffic. But it comes back to what you're trying to capture and for how long and the amount of traffic you're trying to capture. So there is no definitive answer for that. What I would suggest is that, anyone heard of Discord server? There is a Suricata Discord server that you can join, or you can go to their forum and join and ask a question there. Suricata also offers a support contract where they can help you design that if you want. But again, it's a matter of fine tuning. Start small, capture, and if it starts dropping packets, then you know you need to go bigger. But that gives you a rough idea of what you're looking at. Whereabouts, where would I put this? Again, if you're a small organization, I would put it at the edge or at the gateway, where you're going to see the most traffic for all of your devices. After the firewall, most likely, not before, because then you're going to see even traffic from outside that you don't let into your network, which is good if you want to do research. Okay, so you can put it before the firewall. If I was looking after a university again, and I wanted to isolate and figure out where the traffic's coming from, and it was free, I would run virtual instances or small sensors in the different classrooms. So that way you'd be able to quickly identify the location of where that is. Because depending on your documentation, some universities, they do remote wipes and everything like that. They have no idea where the equipment is. They know it's in this building, but whereabouts, they're not sure. So that makes it difficult to then go locate that device. Lab 4 is going to get a little bit more complicated. What we're going to do is we're going to replay it, have a look at our log file, and then see what's interesting in there. But essentially, what it's going to have is some files were downloaded. So we then want to, later on, extract those files. So we then have to set it up to extract files using that file store. So let's replay it first and then go from there. So going back to my terminal window, Control C. Same sort of thing. We're going to have to update our IP address. So I'm just going to replace the honeypot IP with the new IP of 139.59.78.53. So I use the grep command to do that. It didn't help much. Take two. That's better. Yeah, it doesn't matter what lab 3. We'll move to lab 4 shortly. That one's useless. So Control C that. Try it again. That's better. So I'm just doing a search and replace. And now I have no 45. I've replaced it with the 70, the 139. In regards to our file store, just to refresh your memory, this is what is going to be used to help extract files. Currently, it is turned off in our Suricata configuration. So we're going to replay it without extracting files first. Oh, yeah, we can turn it on. That's useless. Because once we've turned it on, we still need to do a few other configurations. So I'm going to update that. The main thing to be aware of is line 47 is where the word no is. So what I'm telling SED is to go to line 47 and look for the string no and replace it with yes. So if this line number had changed, you would need to change this number here. It's just meaning that instead of me looking through the whole file for the word no, and there might be 100 versions of no and replacing it with yes and turning things on that I don't, I've just said jump to line 47, look for the string no and replace it. We need to stop and start the server. And that is useless, that command there. So I'm just going to arrow up. And I may not get status at this point. The latency is really causing a lot of pain. If I type too quickly, it might not like it. And we can see that it's running. So as long as I've got that green active running, that's a good sign. We want to change into the Lab 4 directory, and we want to make sure that we have the logs directory created, and we have now got our packet capture. And this packet capture in this case is a lot bigger. It's 45 meg in size. Created 2020, probably 29th of April. If we want to extract files, there is a extract rule just here. So if we do an ls, sorry, a cat, replayed it multiple times. But what I'm saying is looking at this, oh, it's not even doing that. It's done at ls. Let's have a look. That's it. That's what I want. So the extract rule, it's just an alert. So HTTP, so looking for web traffic from any IP, any port, any IP, any port, file store, all, and I'm looking for this option called file store. My Suricata ID I've set to 1, revision 1. I'm not going to use the custom rule set. I will point it to this when I go to run it. So that is one thing that we're going to be using. To start off with though, I want to run just the replay without my custom rule set telling it to extract the files. So this part is just as normal as what we've done for the other 3 labs. So in this case, it's one file, 45,000 packets. But remember the file size is around 43 meg. And if we looked at the previous one, the honeypot, it had 101,000 packets, but it was only 11 meg in size. So there's a big difference in the packet captures, how many packets there are and how big it was because of the data that's inside the packet capture. So we need to think about that when we look at that. I'm going to start my Eve instance. Oh, I'm not even doing that, am I? Oh, in the past, I usually have you checking instance of it. Okay, so we're going to replay it again. So you need to replay it twice. Usually I tend to do it to replay to populate the Eve JSON file, and then I replay it again using the extract rule. If I use it this way, it's going to be using the default rule set. So those 49,000 rules that we downloaded and updated, it's going through and running that, and you'd get alerts based on that. If I use a custom rule set with the -s, and we saw the custom rule set here, it will only apply that one. So you won't get any context about those packet captures. So just be aware of that. And see how quick it was? Because I only had one, it's only gone and grabbed 5 packets in the, it's gone through all the packets, but it's did it really quickly. It didn't have to go through all those rules. And if we have a look in the logs directory, if I didn't have an issue like this, what we now have is a folder called File Store. Inside that folder is going to be some files. And this is one thing I don't like about the file extraction of Suricata. I haven't quite figured out how to make it more user-friendly, but it's something we'll work on. So first up, I'm going to change the owner. This latency is really annoying. So if we have a look here on the file store, because I ran the Suricata replay as sudo, it's actually created it as root. So as APNIC, the normal user, I don't have rights to that folder. So I'm going to say change ownership on that logs folder and everything underneath the logs folder. So it's no longer root. So now if I do a listing, you will see that it's changed from root as the group, root as the user, to APNIC as the user, and APNIC as the group that owns it. If we change into the file store, we can do an ls, and we're going to get quite a lot of folders. And they're in hex value. So it starts at 0, goes to FF. So 16 times 16, quite a lot of folder structure there. So there's quite a bit of folders. Some of those folders will be empty. Some of those folders will have files in them. So this is another thing I don't like about it. 260. Stop. That latency is really going to bug me. So what we can do is that we can tell it to look for anything in the current directory. That's what the star is, / anything in subfolders. And I'm looking for files in particular. And what it's going to do is look for only files, skip directories, but it's then going to read that file and tell me what type of file it is, whether it's a binary, whether it's a text file, and I'm doing the more command to see one at a time. And so what we can see here at the top, this one's a executable, 64-bit executable. This next one is an ASCII text. At the front of that, it's got the folder. So in folder 06, we've got this big, long file name. So it's like a SHA-256 hash, isn't it? It's in a hexadecimal value. It's not in a human readable format. That's the other reason why I don't like the file extraction from Suricata. But the good thing about it is it extracts multiple in one big go. So I've got this 06, this long random string, the type of file, and down here we've got 1B, 20, 34, 36, and see how it's skipping all of the empty directories. So if we have a look at 1B, that was an ASCII file. It's going to be a real pain. Let me just do Control-C, cat 1B, cat. Let's see if I can just get, I'm just going to cut it. Inside this is a ASCII file. Oh, it's not even allowing me to scroll up. But this is essentially a certificate, so I don't really need to know about this. So it's giving me a listing of update sources and where to get those from. So that one is not malicious. But this is essentially what you do. You will extract the files and then in a sandbox, mind you, and then you would go and investigate what sort of files they are. So what we can do is we can restrict our files search instead of going straight for binary, which are a little bit harder to have a look at. We can tell it to just show me ASCII text. And you can see here we've got our 1B, it just says ASCII text. But then this one, 20 directory, it's got ASCII text executable. So that means it's a bash script or a script of some sort. And so what that second one and the last one could be something interesting to go have a look at. Let's see if I can get my cat. Oh, that one worked. So inside that one, the 201, we can see here someone's written a script and it's attempting to change into different directories, download a file, and then change it to executable, run the file, delete the file. And it's using it for different processor types. MIPS is an older type of processor. MIPS EL is another one. This one is a SH4, x86, ARM, i686, PowerPC, i586, Spark, and so on. So it's basically got all of these different types of files available for the different processor types, and it's trying to download it and run it. In a way, this is going to be very noisy, but the good thing about this, can we see how there's an IP address? So that is a intelligence, threat intelligence that we could use to see if it's malicious. Take that IP, go check with VirusTotal to see if that IP is malicious. The other thing is that then you can use it in your own other systems logs to see if there's been any other communication with your endpoint devices, talking to that, downloading files. Just to save time, I've already got it plugged into VirusTotal, and it's a definite red flag. So I think 2020, oh no, down here, 2023, August, oh no, March, depending on, I can't quite tell if it's, oh yeah, 29/4. So August, 8th of March, 2023, shell script, as well as executable files. So it's definitely malicious still. There are other file types, and in particular, these are binary file types. So there's tools like Ghidra, where you can reverse engineer executable files, or you can open them up and try and have a look at the hex values to see what they're doing. But what I'm saying is go find the grep elf files and show me their paths and the value that you've got there. Based on that, I can go and run a SHA-256 or MD5 hash calculation on those files, and then use that hash value to look it up in VirusTotal. To run that, we can use the this command here, which has too many F's in it. So I'm showing you all my trade secrets and how I do things. So you're learning quite a lot. It took me a little while to figure things out like this, but what I'm saying here is use, starting in the file store directory, so find full stop, look for any type that is a file. Once you find it, can you execute MD5 sum on the file that you have found? So this is going to look at every file in the path and dynamically create this MD5 value. And so that now gives you a signature of those files. And you can now use other tools to then, if you've got a paid subscription to VirusTotal, they give you an API. So you can then use that API and automate this detection process. So you have it so that way you grab the hash value, pass it to the API, it returns whether it's malicious or not. And then you can set up another type of alert for that. To save you time, we're going to take the hash value of those two binary files or one of those binary files, and I've got a link to it for you already. Actually, no, I don't. Just going to open that up. I think there was an issue. You can copy it from here. Yes, I know. I always seem to miss that very first part, so I manually type it in. It's easier for me to do it that way than try and get it. And so now, make sure you click on the search button rather than URL. And in this case, it's clear. So there's nothing there. Oh, no, I know why. I had two hashes. That's what I was looking for. So make sure you only search on the one hash, not two hashes at the same. And we can see here that it's definitely a problem. 50% of the vendors have flagged this hash value as being malicious. So it's a definite red flag. And if I do the other hash value, press enter, there's nothing for that one. If you get this alert, make sure you click on yes. Up here is my timer that's showing me how much time I've got left. We're nearly finished. So what we've gone and done is that we basically enabled our file store capability for Suricata by changing the no to a yes. Then we created, or could have created, a specific rule, but it was already created for you, saying to use the file store to inspect the packet and extract the files. We then tell it to use that rule only, and then we go and have a look for files. Once we find the files, we run it through a hash calculation and go to a third-party website like VirusTotal to see if it's known bad or whether it's malicious, rather than just testing it ourselves. And that's what we did here. We went and did a search for that hash value, and we got a return. With the file extraction, it only supports a few protocols, not all of the protocols. So if it's encrypted traffic, it can't extract it unless there's a way of decrypting it. So HTTPS is a problem. But you've got SMB, network file share, SMTP, FTP. So it's able to extract that. You need a rule to trigger the file extraction. So you can use it to include an extra rule as well as use the Suricata YAML, or we can use the capital S and go ahead and use it that way. Now, there are threat intelligence platforms out there that you can use rather than VirusTotal that will give you information about that. Then you basically want to find out some sort of reputation about the file or IP address, or have some sort of access to a malware database that includes those hash values. Tomorrow, we're going to look at this host-based intrusion detection system, and it gives us a lot more features as well. And this is what the interface would look like if we're doing alerts on that. Now we're going to start writing some custom rule sets. So we're going to do very similar to what I've already talked about in Snort and make some basic rules. So the rules are applied against the packets. And when you want to do something against a packet, so if it's got a particular word, you will alert someone about that. If it's a particular type of traffic, so HTTP traffic, using, say, the GET method or the POST method, and then looking for a particular word, ransom would get you there. The query for your DNS, so if someone's going to www.baddomain.com, you want to be able to get an alert about that. And if you want to set it up as an intrusion prevention, instead of doing alerting, you could do a drop. Our workflow that we're going to use is basically generate some sort of traffic. So PCAP, generate activity on the host, go to a website, test my IDS, and then look for strings or something that's inside that. So you write your rules, then you test your rules, making sure that it triggers what you think it should do. Otherwise, what's going to happen is you'll write the rules and it never triggers because there's something wrong. You've misplaced something or you're not looking in the right thing. So that's the idea, is that you basically have a sample of some sort, or you grab a sample from malware analysis, then you get some sort of signature that you write, and then you test that signature, making sure that you're not using the full rule set from Suricata. So that's why we use the -S to only do a small subset, like what we did in the last lab. Also be aware of the IP addresses that are in the packet capture are included in the home network. When you are writing a signature, you can either write something very specific, especially if you know what you're looking for. So there's a threat intelligence platform out there where other security researchers have found a malicious website or malicious payload, and they say, in this byte of the packet, it's going to have this string. So you could be specific like that. Or if we know it's an IP address, block that IP address or alert on that. And so that's what we're doing there, looking for specific. If it's including something specific in the payload, you might be able to do something like that. If it's not, it might be the direction or the protocol it's using. One thing to be aware of is that there are a lot of tutorials for Suricata, but Suricata has changed a lot in the past few years. So what they tell you to do in 2015 is not going to relate to what you should do in 2024. So make sure you look at the updated tutorials. But just like Snort, you're going to have two sections, an action, a header, and options. You've got the alert. The header is the protocol, the network IP that you're looking from, the port and where it's going to, and the port, and then you've got your options, one or more options. So the action is what do you want to do if there's a match. Alert is the most common one. Drop is if you're going to do intrusion prevention, and log is where you don't do anything but put it into a log file. The header is the protocol, IP address, the ports. The rule is looking for the string, looking for something in specific relation to that, and then the message related to it. And here's a simple example. This is going to be a very noisy one because it's saying alert on any TCP traffic from anywhere to anywhere. And just hello world, TCP. And then a unique number. Some people tend to do it, if you have a look, as the 2020 is the year and the month, October, and then they have zeros, 1, 2, 3, 4, 5. So that way you can write it that way. In regards to ICMP, we can also get traffic by modifying this type of protocol here. This one is doing TCP. What would I need to do it for ICMP? I put in ICMP. Remember, Suricata recognizes certain protocols. To do it for UDP, I use UDP. Does that make sense? So let's have a look at Lab 5, where we're going to be creating some custom setup. Now, there's a Test My IDS PCAP. You can open it up and have a look at it, and you can go view the content of HTTP. But essentially, what's inside this file, www.testmyids.com, it's downloaded a file, and you can go and have a look at what's inside it. So we can see here that there is specific information that is related to this. So the first up, I don't think, yeah, down here, I've got my type of URL. So testmyids.com. And it's coming from this IP address, 82.165.177.154, because it's sending the web page down. That's my source that I want. I also have in the header information, the HTTP response, this particular information about the user, the GID, and the groups. So that's where I get that. So I'm looking for the content in the header of UID equals 0. I've also got the web URL, which is this request here of www.testmyids.com. So I've got that as other content that I can look for. And then I've got the external IP address of the web server of 82.165.177.154. So to create a basic rule, we can use one or more of these signatures to alert on. So we start with the first one, and we're going to say we're looking for any web traffic from any IP, any port going to any, and we're going to say suspicious root privilege because they're trying to change into root. And so I'm saying look for that content. Then I increase my Suricata ID by 1, and that's it. So let's go ahead and build this out now. I'm going to stop my Suricata at this point. And it doesn't work, so let's go back one. So it's stopped my Suricata. I'm going to change into my Lab 5. And it's not a typing test, but if you have a look, LS, I have my rule, which is a text file, my rule 2, which is a text file, and then I've got the PCAP in this directory. So we can have a look at the my rule. Maybe we can't. And inside this one is our first rule that we created, which is the alert on any TCP traffic. To see our IP address, we can do IP address show, and we've got this address of 192.168.30.1. And instead of using Suricata to replay a packet capture, we're just going to tell it to listen on an interface. So what I'm saying here, instead of -R and the packet capture name, I'm saying -I and the interface name. And then I'm still logging it to a custom logs directory, and I'm only using my custom rule. So it's now sitting there waiting for traffic, and you can generate traffic by opening up a web page or SSHing. It's up to you. New tab. Not going to log in, but I got to that point, and I can now use the exit, the Control-C command, to finish listening on that port. And what I now get is that for stats for ETH0, it received 32 packets. And what we're going to get is inside this, we can see our alert being triggered. So the 2020-10-000 AW Hello World TCP, and it's got a priority of 3 coming from 254 going to our system on port 22. So that's our SSH session trying to come up. if we open up the Wireshark for that packet capture, you'd need to download it from the Suricata server onto the desktop here, but essentially it opens it up like this and you can replay it and have a look. But what we're going to do is use the MyRule 2 to have a look at that. And this is where our MyRule 2 is going to have the user group here for our suspicious, and it's replayed it a couple of times. So it's got that one there. What have I got? Content. That's the normal one that we saw in the spreadsheet. Number 5 looks the same, but I've set it to not case sensitive, just in case they change this around. And the information for references or metadata, I've added that in there. It's not a real address. And then here, we're looking for the flow established, http.host, testmyids.com ends with, and then just the CVE that goes with it. So this is just the more complex rules that you could use. Now, depending on how you do it, you can comment out one or more of those rules and test each one to see which one gets triggered based on your packet capture that you've got. So now when we replay this, it only had 10 packets in it, but we can now hopefully get to see what it replayed. And we can see here that it triggered our rule number 6, triggered our rule number 5, and our rule number 4. So each one of those were triggered for different reasons. So I've gone through the rule creation very quickly because it would take me more than a day, more than 5 days, probably more than a month to train you up on all those rule sets. I am still not an expert at creating rule sets. But as I said, what you could try doing is looking at tutorials online. If you've got access to a large language model, it may be able to help you. I haven't come across a proper tool to help you write a rule set apart from that Snorpy that I showed you for Snort. So that will give you a basic creation of a rule set, but it's not complex. It'll be still very basic. The way that you will get better at it is looking at the 50,000 example rule sets that come with Suricata. And that's something you won't get time to look at today for all that. But there's a lot of information there that you can do. Main thing is that when you're looking at your signatures, you should try and be as specific as possible. Use the various parameters or look at the traffic, what you're trying to alert on, and pull that out and then create the rules to do that, then test based on some sort of test packet capture. So what we're going to do now is, for the final lab, is look at another type of malware, which is TrickBot. And essentially what it does, it uses encrypted traffic to communicate with a command and control server on port 449 and 447. So even though the traffic is encrypted, we can still alert on that. Anyway, I'll talk about the MITRE ATT&CK framework in more detail this afternoon when I'm looking at Security Onion. But the MITRE ATT&CK framework allows us to basically have a look at attack patterns and look at the techniques that are used for that. There's also the Palo Alto Networks that gives a tutorial on looking at encrypted traffic, especially for TrickBot. But if we look at the packet capture, what it does is that the TrickBot has communication with this SSL certificate. So we can see here the keyword Internet Widgets Proprietary Limited. And this is part of the server hello and the certificate and the key exchange. So we can go and drill in to that information. And usually that is sent as clear text. So this allows us to look for a particular content even though the traffic is encrypted. And I haven't got I do have the ports up there. So we can see here 449 as the source port. So remember, it uses 449 and 447. It also has inside that exchange on 447 these other information related to global security or the keyword IT department. So you can see here relative distinguished name, global security, up in the organization names, global security, and then we have, what I had, yeah, down here, we've got this IT department. Saves you having to open up in Wireshark. You can go have a look at it. So based on that clear text, we can start building out our alerts for that. So we can say, okay, we're looking for TLS traffic from the external network to our home network. And we're looking at the TLS.cert issuer. So if we have a look here, I don't think I've got it in the screenshot. I don't. So I'm looking for the issuer that has the content of Internet Widgets Proprietary Limited. And for the next one, I do the same. TLS cert issuer, content global security, or content IT department. So there's two different rules for that same type of traffic. We can also use the Salesforce JAR3, JAR3S to try and get the fingerprint and identify whether it is in that SSL block list. But if it's not in that SSL block list, you would go look at the TLS cert issuer information to see if you can get a string out of it that way. So again, just to remind you that the JAR3, JAR3S is using this information here to build out that hash value. So it converts those into a string, converts it into a hash value, and that is our signature. Normally, we won't go through this, but essentially we combine it all together, create a hash value, and we can double click on this and go to a website where they've got a database to check for fingerprints. And you can go and play that there. If we want to use a JAR3 hash, we can then do that using this rule instead. So we can go TLS, same sort of process, but we're doing outbound communication, and we're looking for JAR3 hash value that matches this. And if it matches that, alert on it. So let's see if my latency has gotten any better. So we're going to change into my lab 6. Inside lab 6, we've got these rules here that I've already created for you. It's got the TLS cert issuer, being Internet Widgets, Global Security IT Department, as well as the JAR3 hash. And we're looking for a particular string in this case. We can have a look in our JAR3 JSON file that we've got here, and we can see this string of information, and then we get the digest and the fingerprint. So that's that SSL block list file that you can download. Sounds like everyone's going to sleep. It's a lot of information in a short amount of time. I'm sort of like opening up your brain and just dumping this information in, aren't I? And you're just going, oh. Yeah. Again, I would suggest go over this multiple times. This lab is there for you to play with. Break it. It's not connected to the internet. I don't mind if you break it. So, same sort of process as what we did in lab 1, 2, 3. We replay the packet capture, but we're using a custom rules, and the rules we saw, those 3 that I talked about. I press enter, and it's now going to replay that file, and it's a lot quicker for the 17,000 packets. And my latency is causing issues, but we'll see how we go. And so what we've got inside here, we're now going to see that it's got this TrickBot CNC classification, self-signed certificate, TLS certificate, TrickBot, and so it's picked up that there's the TrickBot in there. Even though the traffic is encrypted, we're using the signature of the JAR3. If you really want to learn more about JAR3, there's a interesting blog that's a few years old now, but you can go and have a look at it. There. A lot of information. Any questions? I'm sure there's a lot of questions there, but no one's going to ask. There is no silly question. I'll check Menti because I've forgotten to do it after each break. So let's see if there's anything on there. Oh, yeah. So referring to the previous question, what do you think about using Parallels VM on Mac OS to create isolated sandbox? Yeah, go for it. You just need to make sure that you use a local host network and isolate it there. I don't know enough about Parallels, but at one point there, especially when you went to the M1 processor, Parallels was the only virtualization solution you had. Create a hybrid machine learning model to detect slow DDoS attacks in software-defined networks. I focused on anomaly-based selection, but the success rate were low. Can you suggest a shift in focus for research? There was a research done out of Uni of New South Wales in regards to software-defined networking, and it was looking at DNS attacks and DNS malicious domains. So maybe I can send you details about that. That's quite old, but he did a couple of talks. So I recommend having a look at that. With software-defined networking, I don't know, I haven't tried looking at integrating it into machine learning, but SDN, you control the controller. So based on that, you get to see the overview of all your network traffic because it all has to talk to that main controller. And then you can start building out trends. So I would suggest having a look at that. Depending on what you're trying to do, detect slow DDoS attacks in SDN networks. So depending on how many controllers you've got, you can see what sort of, I'm trying to figure out slow DDoS attacks. It sort of doesn't, yeah. Normally you get burst, stop, not, because if it's slow, it's going to have to maintain a certain threshold in bandwidth usage over a period of time. So you're either going to increase your bandwidth or you're going to start looking at the source. Which one? Solaris. Yeah, they want to use a hybrid machine learning model. As I said, I can't give details about that, but being able for SDN networks, you've got access to the data from a controller, maybe. Can you brief about the DMZ, demilitarized zone, how it is differ from the honeypots? A honeypot is usually on your normal network. So a honeypot is a virtual machine or even a real system. And that basically sits on your network waiting to be attacked. Now, what you can do is that in your network, you're going to have public-facing services. You then also have private services that are going to be inside your network. So if they're going to be public-facing, a lot of people used to punch a hole through their firewall to allow things from the internet to come into your internal network. That was seen as a no-no a bit later on. The reason for that is once they get inside your network, they can start doing things. So what the idea is that is instead of having your firewall allowing outside in, you basically move your public services onto the other side. And that other side becomes like another firewall here. That becomes your DMZ to run those services out in the public. Now that DMZ might also be a cloud provider. So that way it's completely isolated from your physical infrastructure and everything's public, running in Azure, Google Cloud Platform or AWS. And then you just have an extension there. But the idea of a demilitarized zone is a logical placement of your external facing systems outside of your internal logical network. Whereas the honeypot can be in your DMZ as well as in your internal system. And a honeypot is more an operating system or a machine that runs on the network. And we'll install a honeypot tomorrow. In snort rule actions, what is the difference between drop and S-drop? The easiest way to explain that is I'll go back in my slide. So drop is going to block it and log the packet. S-drop means just get rid of the packet. I've seen no reason for doing S-drop apart from if you're being under attack from a DDoS, because you're basically filling up your logs with garbage. So you would then go in, modify the rule set, do an S-drop while the DDoS is occurring, restart your intrusion detection system, and then just wait it out until the DDoS stops. But normally, in most cases, your alerts are going to be log, drop, reject, or something like that. Is there any policy documents related to the packet analysis in any organisation? If yes, show the sample doc. Oh, packet analysis. There isn't any policy as such, but my next slide, I will talk about why you should do packet analysis. And there are, NIST has a recommendation. In Australia, we have a recommendation where you should be doing network monitoring. And as part of that network monitoring, packet analysis is that. So I'll talk about that this afternoon. How to identify that someone is tracing packets by any packet tracing methods. I don't know. What do you mean by tracing packets? I'm not too sure how to answer that one. So you're talking about if I'm an end user in a network, how do I know if someone's sniffing my packets? I really don't. It's hard to determine that. So actually, there are ways, it depends on your network, because you can look at the degradation of your signal strength. And so if you know what your baseline is, so this is getting very complicated, and this would be for very scientific machines or secure systems, and they know what the signal strength should be between points. And so if someone's listening on that traffic, that signal strength will be less at the endpoint. And so there are techniques to do that. Similar to when you're troubleshooting a fibre, you can find where the break is. So yeah, there could be that way, but that's too technical for me. I'm not that paranoid. Will you discuss about firewall installation? If not, could you please demonstrate at least the pfSense installation? No and no. I do run pfSense on my traditional equipment that I would have here. It's a very simple installation. In regards to that, there's been some rules put in place from pfSense last year when it commercialised. So they've changed that licensing. I was looking at doing a lab. I haven't written one yet for pfSense. So we tried the Suricata with a real-time packet analysis. I think I did that with the rule creation and the my rules. So lab number 5, where we did the -I ETH 0. So we did do that. How to do the traffic shaping? Well, that's another loaded question. There is different ways of doing it depending on the network equipment you've got. But you're talking about inbound traffic shaping or outbound traffic shaping as well. So if someone's attacking you, how do you shape it? Or rate limit? And then if it's going out, how do you shape it? You can do quality of service and things like that. So again, I can't really answer that one. Oh, we've got 2 more questions still. Is it possible to use Suricata and rsyslog server? I haven't used it with rsyslog server, but I can't see why you can't. I've used it with Elastic Stack. So yeah, so if you install something like Logstash, Logbeats, or something like that, you'll be able to tell it to store wherever. So I can't see why you couldn't. Is it possible to find all cyber attacks using a TCP dump file? No. I would have to say no to that, because there are some cyber attacks that are scheduled. So they don't necessarily happen in the packet. So it happens after the users open so for example, malware, if I open it on my laptop, I'm not going to send traffic out sometimes. It might just start encrypting files. So just because I've done a packet capture, I might capture the file coming down, but if the vendor hasn't seen it before, you're not going to capture that. Does that make sense? Yes? No? Yeah. How many of you are listening for mobile phones? Text messages. You can't sniff text messages. Yet a cyber incident could be a text message sent to your mobile phone. So Unless you can control all of the mechanisms to all of the devices, you're not going to get it. How to capture packets in the university server without mirroring port in the switch and analyze it from Suricata. Set it into promiscuous mode, maybe. That would be the only way. I don't know. You need to be able to either have your system in line with the traffic or have the traffic coming towards it. So if you're in an isolated VLAN, even though you've set your NIC to be in promiscuous mode and to listen to all traffic, it's not going to give you all the traffic because it's only showing you what's on that VLAN. So without having control of the network, yeah, it's going to be difficult.
Tracing, there's a lot of direction, something like this for traffic tracing. But the requirement is there when we considering Sri Lankan countries. There are no proper legal involvement still in the rules, but all the companies and organizations, they have to comply with the ongoing audit kind of thing. So, in ISO audit and NIST audit, both part is covered in the under the business continuity. Inside the business continuity, we have to identify the risks and we have to detect it and analyze it. Inside that also, this packet capturing part is covering. So, under that particular item, when we are doing that audit, that auditors will be looking at what are the mechanisms used in your company organization to analyze what means like ideas kind of solution. So, other than that, for the access control kind of things also, the same similarly, it is going on. Sometimes we have to, for the server side or application side itself, we have to do this controls. Otherwise, we have to go for some kind of solution like PAM servers. And for the vulnerability assessments kind of things also the same. And we can do manually the servers, or we can do it for vulnerability assessment and get it done. So they are accepting both the ways while we are doing the audit service. So there's a requirement they are giving us to comply with the those audits. Normally, the telecommunication side, TRC is specifically this similar audit. There also they are checking whether we are agree with this records. Okay. And another question came that how this servers kind of thing can expect is identified with something. And,
You might be better off using a darker colour. Green's hard to see up the back.
so if at a server, there are few models there. And it's packet capturing. Then we are recording. Analyze. And only whatever the processing will be happening. So we have to the question asks that how these modules will be placed in the in particular network. In our network. Suppose we have one ISP and it has network tracking. So in terms of here we can that we have hosts and they are connected with some switches and firewalls, and then it's going to this firewall and it's going to internet. For this packet capturing and this recording, analysis, and processing kind of this, this server can be internet. inside the network we can have it, just like our data center and everything. But we have to make sure this traffic in each point we are sending into this packet capture. What is different techniques using? One is to, if it is at the internet end, it will appear like what monthly kind of thing. And some other enterprise, something like if we want to monitor this each interfaces separately, we can mirror it and get the traffic into this particular capturing thing. And when it comes to hosts, there will be some agents, kind of models we can directly without putting the traffic capture also, that also possible. But for the host specifically, there can be mostly. So there will be some agent, small modules, and that will be implemented, and they will be capturing whatever the actions and the logs kind of things, and that will be sent to this capturing or the log analysis module. So there we need a server, but we don't need to implement the servers in all the places here. Just it has some agents you can put it to our hosts, or we can directly cut the that means directly mirror the traffic convoy and put it to this array.
I might just add a few things. So is this more, how would you set up a Suricata system in your network? Is that what someone's asking? Yeah. So there's a couple of ways of doing it. If you've got a small network, you only need one server with the throughput and the hardware to do that. If you've got a larger network, what you would do is, so what you can do is that you can have a central system that's going to be logging your packet capture. So it's going to start doing your capturing. And that's if you're only doing one system. Now, at the same time, if that's capturing packets and you start replaying packets or doing alerting on that, you're putting extra load on it. So ideally what you would have is a workstation that's going to have the software installed that takes the packet captures and does the analytics on that. On top of that, once you want to build it out more, you can actually get Suricata running on smaller devices as a sensor. So you then install these sensors that grab the traffic and then forward them to this central system. So you would then have multiple sensors that are going to get the packet capture and forward it on. There is that model. If you've got the resources, you can have each one of these actually alerting and doing the analysis of that. And this will be your back-end log server that receives those alerts. And then you have your analysis system that goes and talks to that. After the break, when I start talking about a network security management software like Security Onion, I'll show you the breakdown of how we can set that up. And it's using Docker containers to run a lot of these resources in a standalone, or you can have it in an enterprise version, which is where it breaks out each of these modules into different parts of your network. And that might make a little bit more sense, but ideally, at a minimum, you would have one big beefy box that then is either receiving all the traffic and doing the analytics on it, or you have one or more sensors that sends the information to a beefy box that does the analytics, or you have one or more sensors that are very have all the processing power to do the alerting, and then they send it to a centralized log system. Okay, so there's different models that will suit different reasons for that. I hope that helps. Any questions? Any more questions? Are there any difference? Mainly the rule sets are the difference, and you get support from the paid.
Other than we can
Yeah. So the sensor, you'd need a Suricata sensor to talk that way. Depending on your security management tool that you're using. So for example, Security Onion has both support for Suricata and Snort, but you can't run both at the same time. So the setup I've got, because I preferred Snort, is it's using Snort in the lab environment, but you can convert it over to use Suricata if you want. And that's because what it's using is another third-party tool called Logstash to basically take those logs and puts them into a standard format that it can read. Yeah. And there's other tools out there. Seems that's what they're good for, is basically pulling in various types of logs and getting a way of displaying those logs in an understandable manner. So getting a good, so tomorrow, so if you've noticed, each day I've been building on the previous day's skills. So day one was all theoretical and doing some very basic stuff. Day two was very manual, going through and doing a pen test, a vulnerability scan to see what's vulnerable on your network. And then end of day two, we started looking at packet analysis, so detecting things happening on your network. And that was very manual. Today, we're still detecting things happening on your network, but we're able to do it a lot quicker. This afternoon, I'll show you another tool that puts it all together. So hold your questions until after tea, afternoon tea, and then we'll go on to that. I'm happy to start early. Normally, I can do this session in 2 hours to 3 hours. We're going to skip some of the theory, not much, because I think the theory is still important, but we'll come straight back, start the lab, and then I'll go to the theory, skip between that. But what we've got, actually, no, I might do the theory first because it just cements some of the questions I've been getting already. So I'll just jump to it. So this is the model that I was referring to with Suricata. I can do it as a standalone mode, not Suricata, with Security Onion, and it basically installs all this software on the one machine. So you do need a beefy box to do that. Or what you can do is you can break it out. So you've got your analyst's machine that then connects to this one beefy box that runs all this software, and then you have your different sensors out there. So here we've got Snort and Suricata as our network intrusion detection systems. Then we've got our host-based intrusion detection systems, and then we're running other log systems to be able to feed into the Logstash. Elasticsearch is then used to display it or index it. And then you've got other scripts that will run to get extra information about those logs. And then you can use visualization tools like Kibana or Grafana to go and visualize that if you like. There is no one tool suits everyone. But I do like this one because it's very customizable. With that in mind, I think it's time for a break, and we'll come back in, say, 20 minutes and start the next part. Yeah. For those who just came in and everyone else, can I get you to start your Security Onion lab? It's a very beefy lab, so you need to make sure it has plenty of time to boot up and run before we cut over. So can I get you to launch the lab? And it will take a good 10 to 15 minutes to start all of those back-end software that's going to be running. So in regards to packet analysis for your network, I'm going to go into more the theoretical side. And so this is something that you may want to use to convince your management on why you should be doing some sort of intrusion detection or packet analysis. Going back a few years, over a decade ago, the then leader of the FBI, the Federal Bureau of Investigation, said that I'm convinced there are only two types of companies, those that have been hacked and those that will be. So everyone's going to be compromised at one point. So you just need to be prepared on what to do if it does happen. So we're going to go through a very quick overview of this different areas here. But to give you a good reason of why you want to see what's on your network. In 2018, when I first started with APNIC, the first workshop we set up, we ran a network security workshop in Noumea, isolated part of the world. So we ended up setting up our honeypots in a cloud instance. In that cloud instance, we ran it for 24 hours. And we got over 21,000 attempts to Telnet or SSH into those sensors that were in the cloud. One of those had over 8,000 attempts to get into that system. 8,000 in 24 hours. That was in 2018. This honeypot concept, we've expanded that. APNIC has a HoneyNet project, and we've got multiple sensors that we are now giving information to our members for free. And it's called Dashboard for Autonomous System Health. And the idea is that if we are seeing IP addresses from your address block, we will tell you about that. Because in theory, your prefixes shouldn't be trying to log into my honeypots. Okay, so that's freely available. If you've got login details, you can go there if you're a member. 2019, so 12 months on, a vendor called Sophos, which is an antivirus company, they tried a different experiment. Instead of setting up a simple honeypot like we have for SSH and Telnet, they set up a remote desktop protocol honeypot. So how many people know about remote desktop protocol? A lot of Windows systems use that. And so they set it up, but not in one cloud instance, but in different locations around the globe. And they let them run. The first attack happened within 1 minute and 24 seconds. 1 minute and 24 seconds. Not even enough time for Shodan to find it. And that happened in Paris. The longest time before one of the systems were attacked was 15 hours and 26 minutes and 27 seconds. So all of them were attacked at one point in time. They left them up for over 30 days, and over that time, they had over 4.2 million attempts for login on 10 devices. So imagine what is happening to your public-facing systems today. In Australia, they're starting to see that there's certain infrastructure that is critical to the running of the nation, as well as the data that the businesses are collecting is sensitive. So in Australia, we have this notifiable data breaches scheme. So we're going to have to tell the government if something's happened, and we have to do it within a certain amount of time, and then we've got to notify the users involved. India has got one as well, and halfway through last year, they did another one, which has upset a lot of security professionals and a lot of networks, in the fact that you have to tell them, I think, within 2 hours of a data breach. 2 hours. That's unreasonable, because in most cases, companies don't even know they've got a data breach until 2 months later or 1 year later, depending on how stealthy it was. China also has different laws coming in place. And if you're interested, this is a useful website where you can do a comparison of the legislation regarding to data privacy and cybersecurity. So you can go in and select, say, Australia and Sri Lanka and see what laws are in place in comparison between those. Anywhere where it's red means that we are heavy regulated quite a lot. So Australia is regulated heavily. Anywhere that is green means that there's some limited regulation there, and grey means I haven't found anything yet. I've got another one, Atlas Policy, that does a little bit more on cybersecurity policies. I haven't included it there, but I'll put it up on the events page later on. So going back to this attack life cycle, in most cases, if you're listening to your network traffic, you're going to be able to pick up some of this initial compromise and other recon around there. And also, if they're exfiltrating data, if you've got the appropriate mechanisms in place. In Australia, we had this recommendation for mitigation for any sort of incidents that occur. And on one of the pages, it talks about some of the strategies for cybersecurity incidents and responding. And in particular, you can see here we've got this host-based intrusion detection, network-based intrusion detection, and capture network traffic. On the left-hand side, it talks about how effective it is. So continuous incident detection and response is excellent. Network and capture are limited because if you're capturing, you then replay it at a different time. So it's more for the incident. In regards to users' resistance, well, they don't need to know about it, really. So there's low resistance. Depending on what you're trying to achieve, there may be requirements for education of your staff to be able to use that. And that's where vendor solutions come in. So you're quite happy to pay a vendor to set it up for you and get all the support. And so your upfront cost may be high for the staff, the equipment, and technical complexity. And then depending if you're using a vendor solution, the ongoing cost may be high as well. In America, they have this cybersecurity framework, and it refers to these 5 identify, protect, detect, respond, and recover. In regards to our security monitoring, this section here, the detect, is what we're focusing on. So if we drill down on that, it talks about anomalies and events in the detect functional area. In particular, it's got 5 of those there. So you can present this to management and say, look, in America, there's this NIST cybersecurity framework, and to detect, we should have a baseline of our network. We need to detect events and then analyze those events. And then being able to correlate multiple events from different sources. So you might have one particular IP address trying to log into the router on this campus, and then you might have that same IP doing it at every other campus related to this university. So therefore, if you correlate that, you might think, if you just only saw the one event, you think, oh, don't worry about it. But now you're seeing, say, 10 or more events from that same IP address, someone's trying to break into the system. So it becomes more suspicious. On top of that, there's all these other standards that you could go and reference as well. I'm not going to break into those, but you're quite welcome to go and grab and search your friendly neighbourhood search engine to read more about it. But they've got this special publication from NIST again that looks at auditing, continuous monitoring, incident handling, and so on. Another tool I've referenced already is the attack matrix for the enterprise. And there's a lot of good resources there, but essentially what you can do is drill down in a particular area and it will help you look for mitigation strategies for that. From a packet analysis, I've sort of alluded to this yesterday, I think it was, when we were talking about T-Shark and Y-Shark, but you're basically looking for something that is malicious traffic and has distinctive marks. So when we looked at Lab 4, I think it was, or Lab 5, where I was looking at the URL and the certificate names, they were distinctive marks to do that. What I mean by that is things like the IP address, the web address, the host name, any sort of header information that could be in there. Yesterday we used the Nmap tool, and I said it's a very noisy tool. We can actually look for the user agent string that has the keyword Nmap to see that it's being used to scan my network. And so this is a simple Suricata and Snort alert. That used to be the case. I think Nmap's now removed that user string, so it's no longer that, but you could use something like that to determine if someone's doing a reconnaissance on your systems. And we can go in and have a look at this user string here. Example could be detect Nmap scam of network, looking at the user agent string, and we can see here grep in Nmap. So what I've done here is I've looked at a folder of all these different packet captures for cap in do this cap, and then I'm saying replay it, look for the user agent string, and then save it in the user agent.txt file. And then when I do that, I can now see on here that I've got multiple scripting engines happening inside that. So I've been able to replay and discover that someone's doing an Nmap scan in my network. The next thing is, instead of doing signature-based, which is very easy to bypass because I just need to change one thing and that alert will no longer work. So you want to start looking at this session, the overall, what is happening with that session. So you might get some legitimate traffic of someone doing a remote login to a system. Nowadays, because of COVID, it's usually most organizations have remote access, true? And so with that remote access, that's legitimate. But then that system might start uploading to a cloud server all of these sensitive documents. Is that legitimate? Possibly not. So they're trying to exfiltrate information. So if you only looked at the login details and that was correct, then you wouldn't do any more investigation. Whereas if you look at the whole session and you start seeing that they've uploaded 6 gigs of information to Dropbox within 30 minutes, that might raise alarm bells. So looking at the session and the behavior of that session is what's going to help with that. The other thing might be the device itself. As I said this morning, a lab computer in this classroom, should it be accessing the payroll server somewhere in HR? No. So you can look at the device and where it should be communicating with, as an example. The type of traffic, what is being transferred, does it look normal? And we've looked at things like yesterday when we looked at that ping packet. It had extra information in it and it was a lot longer. There's a technique where we can use DNS to send information outside of a network because people, or most network engineers, leave DNS open to the world. So you can go and query for what is www.google.com. So in this example here, what's happened is that the malicious person has compromised the system. That system has details about the IP address, what sort of operating system it has, the username, the host name, and the IP address. So what I would do as a malicious person, I run a simple script to gather that information, run it through a base64 encryption so it doesn't look recognizable. And then I would do a query for that big long string to my domain controller. So that big long string .badsite.com, it's going out to the internet. My DNS server is listening for this information, and it basically strips out the bad.site, takes that string, converts it back, and stores it in a database. And I think I may have a DNS tunneling example later in the week. If I don't, I can point you to one that I've done. So in this case here, you get this really long DNS string. So you can do a Wireshark filter to find that. So anything over, say, 20 characters, you alert on. So which technique should you use? Signature or session? I suggest both. In most cases, you're going to use the signature to get the alert first, and then you're going to investigate the session. Machine learning's making it easier to pick up the bad behavior. I'm not an expert at the machine learning side of things. That's more vendor world type stuff, but you could potentially do that. In regards to doing this detection, there's a whole heap of different open source tools that you can use. We've currently been looking at Suricata, Wireshark, T-Shark, but there's other ones out there that will help you with that. So Logstash, Elasticstash, they're all techniques to store the information that you are getting alerted on. Kibana is a mechanism to show you that information in a visualized way. Snort and Suricata, as I've talked about already, are intrusion detection systems or intrusion prevention systems. Zeek is another powerful analytic tool that you run a PCAP through, and it gives you all these log files, and we'll look at that, I think, tomorrow. It used to be called Bro, but when they tried to sell it to enterprises, it didn't really fit well with the name. So they changed the name to Zeek. And then there are two tools. One's called Squirt and Squill. And we'll use both of those this afternoon. They basically are a web GUI to the alerts that are generated from Suricata and Snort. So we'll be looking at that. So one allows you to just get like eBox, the alert. The other one allows you to go back to the packet capture and drill down further for further analytic analysis. Packet captures, I've talked about those already, so I won't go over those again. So what we're going to do is, I'll skip past this. If we get time, we'll come back to it. But we're going to jump into Security Onion. So we've got a virtual machine that's running in the Academy, and I'm running an older version of Security Onion because I find this a simple way to introduce you to it. Excuse me. It has a web, it's basically a Ubuntu desktop, and it runs a Docker instance. The newer version is just a Ubuntu server with no desktop, so you need another system to connect to it. And so that's what I've done it this way. Essentially, you're going to have at least two networks. You're going to have a management network where you can connect to from the back end, and then you've got the network or networks that you want to monitor for bad traffic. It's going to either be deployed in a standalone mode or in an enterprise mode. The version that we're running is deployed in a standalone mode, so everything is running on that one VM. It's going to run a whole lot of software. So it's got Logstash, Elasticsearch, it's got these Python scripts, it's got Elastic Alert, and it's also got Curator to get rid of old alerts. And then it's got your sensor for detection, and it's got Bro and some other syslogs there. It's quite easy to install. I don't think that is valid anymore, but if you do want the ISO for this version, please let me know. I have a copy, so I can share that with you. But you can still go to the Security Onion Solutions, and you can download the latest version, which is version 2, I think, from memory. And that's Ubuntu 18 or 20. From memory, I can't quite remember. Once you've got it installed, it uses custom commands. Everything that starts with SO is for Security Onion. So to do an update on Security Onion, you do sudo soup. You don't do the sudo apt update because it may update some of those components out of order and break your system. We're going to use the SO status to make sure that everything in the back end is running properly. You can also start, stop and restart the service. You can do rule updates and you can allow certain firewall ports open or view those rules. The location of our files are different to what we're used to. For Suricata and the rules that they create. So we can see here most of our configuration files will be an NSM directory. We have our settings here. We've got the Bro or Zeek logs located there. We've got Elasticstack and other logs there. This is one of the big advantages of the older system. It comes with a whole heap of sample packet captures already there. Whereas if you do the newer system, you've got to find your own sample captures. The rules are not in that var location where we said, the lib and so on. So they've been changed to this NSM, Network Security Monitoring, rules directory. And we've got for snort, pull, pork, and then we've got some Elastic alert searches. So anywhere where you're going to have modified or disabled rules and you're going to use snort and you want to update, you would need to modify this file. So they stay disabled and they stay modified. To replay a packet capture, there's a couple of ways to do it. You've got sudo TCP replay, the interface that you want it to listen on, and then I tend to throttle the bandwidth. So it only runs at 10 meg. That's what the dash capital M means. fake_av.pcat. If I want to import everything in a directory, I can do the so replay, and then there's another one that does that. Now, when I do the replay, it's going to replay it with the timestamp of today. If you need to do incident response that looks at the original timestamp, say for a court or police investigation, you may need to use the SO import PCAP, which keeps the original timestamp. Another tool is cap infos, and this is where you can get metadata about when that packet capture was created, how big it is, how many packets are in it, and so on. Security Onion, this version of Security Onion doesn't support next generation packet capture files. So if you come across the next generation packet capture file, you need to convert it back to the older format. And this is using T-Shark to do that for you. So I'm basically saying T-Shark, format is PCAP, replay this file and write it to this file. So that's another reason why you use T-Shark. So what we're going to do is, I know these are malicious files, so we're just going to replay just these files. Normally I will get you to replay the whole lot, and then you go looking for a needle in a haystack, but that takes 15 minutes just to replay all those logs. So we're not going to do that. We're just going to focus on these two packet captures. So we're going to do sudo TCP replay -I. The interface is ENS33, limit the bandwidth, and then the packet capture that we want. And we do that twice. Once we've got that in our system, we're going to open up a tool called Squirt. And I want you to think about these questions. Can you determine if there was malicious traffic? And if so, what is it? And then look at what is the top source IP address and destination IP, and what is the other IP address that top that IP address is communicating with, the top source IP. So let's go through and flip over to our lab. So I'm going to use my window here to fit machine to window. Opening up my command prompt. And if you want to see what your IP address is, you can do it IP show ENS31, and we've got this 30.1 address. Main thing is that we want to look at our status, and the password should be training, and you can see all of these Docker instances running in the background, and they should have OK against them. So this system's running at least a minimum of 16 gigs of RAM and 4 virtual processors. So you do need a beefy box. You can drop it back, but when you drop it back, sometimes some of these services do not start up. So just be aware of that. So you can drop it back to 8 gigs. If you've got all green, move on to the next part, and we're going to change into our sample packet captures directory. Inside here is a lot of different packet captures that you're welcome to play with and replay to your heart's content. You could possibly use T-Shark, Wireshark, or whatever. We can see one that's got a suspicious name already called Fake AV. So if you use the cap infos on that file, it will give you the metadata associated with that file. And we can see here the number of packets, how big it is, when it was captured, or how. So this is from 2011, and it was only lasting for that many seconds, 1,063 seconds. It also gives us the hash values to see if it's been tampered with, and then some other summary here. Now, these hash values are important, especially if you're going to present this as evidence in court, at least in Australia. It's important from that point of view, because it's your way of proving the chain of custody and that it hasn't been tampered with. So I'm going to try and replay the first one, and it should do it okay. So sudo TCP replay -I, ENS33, bandwidth 10, and the sample. And what we should see is the attempted packets matches the successful packets. If it doesn't match, it means that it's going too fast, so you might need to limit this or increase your RAM and processing power. I do the same for my second one, and I've got that there as well. So that's a good sign. Hopefully everyone's been able to do that. On the desktop is an icon called Squirt. You can double click on that, or if you're a command line person, you can type in Chromium browser and the web address to open the Squirt. For whatever reason, there's some sort of keyring thing trying to allow you to open up a web browser. I haven't figured out how to turn that off. If someone knows, please tell me. But type in training, and it doesn't help that it's got that many characters. And because we're trying to connect with a self-signed certificate, it gives you a warning. So I go advance and proceed to localhost. we're going to use the user APNIC. Not that way, so I'll do it this way. So up here, type text, type username, APNIC. Up here, type text, type password, training. And it now brings you into this web interface. Nicer interface than EVEBox, isn't it? On the left-hand side, it's showing you queued events, total signatures, how many have been set with a high priority, a medium priority or other, different types of classifications down there. On the right-hand side, it's going to now show you the queue and the grouped items that have been detected. And it will say how many, 7 of 1, 5, and so on. So we can see here straight away, there's some alerts about a suspicious doc.exe file. It also shows me a visual representation of how many critical alerts I have, medium alerts, and other, which is the same as over here. The other thing was, when we used Suricata and we opened it up in EVEBox, we got no alerts because of the time filter. When we did that replay, it replays the packet with today's date and time. So that's why it's showing these alerts. So it's modified that timestamp. So what we want to do is jump to the summary page. In the summary page, it's going to show us an overview of the packets. So there's 321 packets, or sorry, not packets. It's going to show us the alerts. And there's 321 alerts that are remote access Trojan, encrypted session to command and control server. It's got another Trojan backdoor family being PC rack, CNC traffic, outbound, and then some more. And then there's some other malicious information there. If we scroll down, we now get a listing of our top talkers from our source IP to our destination IP. So we can see here our source IP of 172.16.150.20 is our top talker. So you might want to think maybe this is suspicious. That is our infected machine if it's in your local network. The outbound traffic is going to Hong Kong. So again, that is a bit suspicious. Or it may not be, depending on what you know as normal. So we can see here the top destination country has been Hong Kong. And if we scroll down, because I don't have an internet connection, we're going to have some missing information, but we can see our top source ports and destination ports. And scroll down. Normally, if it's got an internet connection, it will try and show you where on the globe those IP addresses are. How many of you are going to go back to Wireshark and T-Shark tomorrow? You'll probably stick with this. Can I get you to click on views? From our views, we get a Sankey diagram showing you a percentage of where the traffic is going to. The thicker the line, the more traffic is going in that direction. In this case here, we've actually got 3 IP addresses. We can see the majority of the traffic is pointing to that Hong Kong address. But then we've got just this small line of traffic going to a server in the United States. Do you think that's suspicious? No. Or it's worth investigating? So we want to go and have a look at this IP address. We would definitely look at this one here and this one here and be able to figure out what's happening with that. If we're controlling this one, so this is inside my network, I would be doing a format on that because I would assume it's definitely compromised. So what we're going to do is we're now going to look for other alerts in relation to that. So we're going to go back to our events and we're going to filter for that IP address. Hopefully, it did it. I was doing it slowly and it still did it. That's annoying. I'm going to do it this way. Make sure my cursor's in the right spot. And so now I can filter on that IP address and I get all the events related to that IP address. And so it looks like suspicious star.doc.exe in the URL. So normally when malware gets into your network, it uses multiple locations to drop a payload onto your network. So it first connects to maybe send you a phishing email. You click on that, it goes off, downloads the software from one IP address or one location. It then installs that and it may download some other payload from other locations. It installs that and then it starts communicating with a command and control server to start exfiltrating data. And that's what we've seen there. We've got this big thick line of traffic going between two machines. But there's this one small line in that Sankey diagram. So what we can do is that we can move from this alerting system here into the raw packets themselves to see what that information is. So we're going to go to our other system instead of Squirt, we're going to Squeal. So I'm just going to minimize this if it works. Minimize. And we want to go here. The username is apinic. The password is training, all lowercase. That is wrong. And if I've got it right, it's going to show me this here. Now, the thing that you need to look at is which network monitor you're monitoring. So I'm going to go to the ENS33. I'm hoping that's the right one. And this one here is my host-based intrusion detection system. So I'm just going to tell it to monitor this one here, and I go start Squeal. And this is going to have a different layout connected to that Logstash. Down in the right-hand side is the actual rules and the packets that you can view based on the alerts up here. So we're going to start looking at query similar to what we did previously, and we're going to do query by IP. I'm not going to trust that I can do it. So I'm just going to try and type it in that way. So I'm doing a query by IP. And I click on submit. And I get 2 alerts returned. So I've got some orange ones and I've got some red ones. If I click on the first red one, and I place a tick in show packet data, it's going to give me a nice little view down here. The source IP, the destination IP, all the IPv4 header information, and the flags, and the data itself. If I click on the show rule, this is going to go and show me, in this case, the snort rule that was activated on this packet. I can't change my window size. Unfortunately, I can't change it, so we'll leave it like that. But you can see how you got the alert from the external going to the internal, and it's got this Windows file download over HTTP. If I want to, I can also right mouse click on this. Not what I wanted. Let's go over to the alert ID. Come on, let go. So on the alert ID, right mouse click, and I can now click on Wireshark or transcript. So if I click on transcript, this is going to basically pull it back together, that conversation. And we can see here that it's a get command. So it's getting this file document here. What's the name of the file? swing-mechanics.doc.exe. Okay. So in a matter of a few minutes, we've been able to replay a packet capture. We can definitely find malicious traffic. So Trojan traffic, CNC traffic, and downloaded the malicious document. The source we saw has that 172 address going to a Hong Kong address. Then we saw that it had another communication going to that 66 address in the US. And we can see this as the different screens. So we went to the summary, determined the traffic, the top talkers we saw in that section. Then we went to the views for the SANKEY document. Now this view is where I've replayed every packet capture to make it a little bit harder for you to find it, but it does stick out. You've got this big grey line, and then you've got this smaller red line going from there. The next question, what was the rule that generated the original alert? We were able to go and get that from doing a query for that, and we can see that down here. What is the file name of that downloaded suspicious file? We can have a look just here. We've got it right here. swing-mechanics.doc.exe. And I've pointed that out there. The next thing is, can this file be downloaded? The original file be recompiled from the packet capture? And yes, it can. So if we go back here, close that down, right mouse click on the alert ID, open it up in Wireshark, it's going to say, hey, this could potentially have malicious traffic. It did it without me clicking on OK, so that's OK. And we're now in this view, if I right mouse click and go follow TCP stream, it's going to show me the same view as the transcript. But what I can do is on the file menu, I have this option to go export packets, and I can select web traffic. And from the web traffic, I can see I've got this one file. And you can go click on save. And it's going to ask, where do you want to save it? Now, my suggestion is that you don't save it as the executable. Save something else to it, or put something in there that is like malicious. Oh. Ah, I can't win. I'm just going to say bad. I'm going to say that in my home directory and click on close. So I'm able to extract that from that packet capture. And it talks you through how to do that there. Going to close that and delete it. Another tool I would like to show you at this point, I don't think I've got it in the lab, but if you right mouse click, there's this tool called Network Miner. Now, if you are new to packet analysis, or if you're a teacher and you're showing students and they're not quite grasping the concept of Wireshark, Network Miner is a great tool for you to use. It breaks it down into smaller chunks and lays it out very nicely. It doesn't give you the exact packet capture, but it extracts all the main things that you want from a packet capture. So here, it's extracted the IP addresses of the communication, and it's determined what it thinks to be the operating system. It then groups those with other information. So now it gives me key information that I can use to start doing analysis with. Click on host details, and it's going to tell me it's got one server banner. It's a web server using Apache. So this is from the packet analysis. This has gone and had a look at the HTTP header information and built that information. On here, I've got, on the Files tab, I've got the file already extracted. So this is what I would use if the packet capture is not too big to do file extraction, rather than use Suricata's tool of the file store. The reason for that is I get the original name. Sorry for Mac users, I don't think there is a Mac version or Linux version of this tool. And then I can see things about the session, any sort of parameters that have been passed, so user agent strings and so on. Yeah, there's quite a lot of information that is pulled from those packets. So you can see that information there. In some cases, it's able to pick up anomalies, but there isn't any there, and that's it. Once you're able to extract a file, just like what we did with Suricata, we ran it through a hash calculation and got a hash value. I don't think I'm going to trust my system to do the hash value, So I'm going to go to VirusTotal. Open it, new window. Oh, what the? That's not what I wanted. Open in new window. What? It's this has gone really bizarre. I'm just going to copy this, go here, paste this, and I'm going to go to VirusTotal, the manual way. Go to the search button, and I'm going to paste in my hash value, and we can see here the hash value. It's definitely malicious. Last seen 2 hours ago, and it's basically called swingmechanics.doc, and it's a Trojan.poison ivy threat category. So you can then use that to find out more details about what it's trying to do. So that one is definitely suspicious. I wasn't expecting that, because the last time I ran this exercise in December last year, I think it was all safe. Whereas it's obviously coming back into fashion. And we can see here that there's a lot of communication about this string. So verdict is malware from Joe's sandbox analysis, and it's poison ivy. So we now have been able to replay some packet captures and determine whether it's malicious, and we've gotten evidence of the original downloaded file. We've been able to extract the file. I didn't demonstrate how to do an MD5 hash because I think my latency is going to have too many characters come out. And then from there, it's basically showing that we've got the MD5 sum on that document, gives me that value there, and we can see that it's got definitely malicious intent. So the reputation is bad. What do you think of Security Onion? Now, that is one of many tools that is referred to as a network security monitoring tool. We'll look at another one that integrates a lot more tomorrow. There's another one that a friend of mine at Team Kimaru likes, and that's called ROC NSM. I've been meaning to write a lab on that, but I haven't done it yet. But you're welcome to investigate that. I'm going to see if I can do the TCP dump lab in 15 minutes or less. Now, most of this we did similar in T-Shark. We basically use T-Shark-R, replay the file, and then we use various tools in Linux to manipulate what information we get from the packet capture. So it's very similar to what we did yesterday. Only difference is this -NN, and that means don't use DNS to resolve the IP address to a host name. So it's very similar. We replay the packet capture. We see how many packets are in it. We look at how it's laid out by looking at the first 10 lines, and then we start cutting information from it. This one here is going to basically look for our TCP or UDP protocol, look for the spaces, take field number 5 From field number 5, it's going to take just the IP address, and then it's going to sort it, count it, and do a reverse sort. So the most counts will be at the top talker. In this case, the top destination. So that's what that field is doing there. If we are investigating suspicious domain names, what we can do is look for only port 53 traffic. And then once we get just port 53 traffic, you can then start looking for domain names. Now, in most cases, or in the past, it was too expensive for malicious actors to have their domains hosted in a US domain because they would have to pay US dollars for that domain. So they usually host them where it's free or where they can get a cheap domain. So what I'm saying here is to exclude any domain names with those in it. Once I've done that, I then tell it to get field number 8 and look for anything with characters in there. That should give us a whole listing of domains. Now, to do that same concept for a folder full of packet captures, so instead of just looking at, in this case, fake_av.pcat, using a CLI tool, I can tell it to look at a directory full of packet captures. And in this case here, I go to the MTA directory and I use a for loop to do a listing of the packet capture. Every file name gets put into this variable, and then I tell TCP dump to look at that file name and then do the same process as before. And so it can look at 10, 100 different packet captures and pull out all the strings related to the domain name. This one is doing the searching for clear text passwords inside various protocols in a directory full of packet captures. So that will make it a little bit quicker for you to investigate if someone on your network still has older technology running and they're trying to log into that older technology. So if that was the case, you would then identify the IP addresses of those and hopefully the username, unless it's a generic username like admin, root, or something like that. And then you would try and isolate those or encourage them to use an SSH tunnel so they don't need to do that, or move them to something that's a more secure protocol. So let's have a look at some of these examples and how they would work. I don't think I've added the TCP there yet, no. So what you need to do is on the events page, I've got this TCP dump lab that you can go have a look at. And it's going to step you through each one of those with screenshots. And it breaks down what I'm trying to do in each of those. So let's see if I can get my latency to work. So I'm going to go back to here. And I'm going to run the just going to put that on one line. So what I'm saying is to have a look at the fake AV and pull out, pardon me, the top IP addresses from that. Now, just to show you, if we do let's see if I can do a TCP dump. Oh, it's working. I spoke too soon. So I'm just showing the first 10 records of that. So what you see is the timestamp, the protocol, the IP address, but it's got a full stop port number going to destination, IP address, and full stop port number. And then it's got the sizing, depending on the protocol. This is a DNS one. It's got the sizing, the type of query, and the query. Whereas this one is doing IP again, but it's got the flags, the SYN, the FIN, the reset, and the push flag there. So this field number 3 that I'm looking at is my source IP address. So if I want to look at my top talker, that's what this is doing here. It's grabbing a listing of all the IP addresses and which one's doing the most communication from that fake AV. To modify it to a different one, you can do this query here. So the destination, instead of field number 3, it would be field number 5. And that will be the top destination. To look at domains doing queries that excluding .org, we can look at this one here, or we can go into more detail to try and find a very unusual type of domain. So if we have a look here, this one's going to extract only English type domains. So if you've got an internationalized domain name, you would need to change the query here to include that. I'm not too sure how to do a regular expression for that, so I'd have to look for a way of doing that. That could be a good research project if someone was asking about research projects. Ideal for here. So we're going to go to our lab and we're going to, again, I'm not going to try and type it because my latency, but I will paste that in there. Click on OK, and it's now pulled out of that all English-based URLs. And to me, that looks suspicious because of where it's located. But you would then take that and look up the reputation using VirusTotal or DShields. Scrolling down, we can get very complex searching and we can look for all sorts of domains. Let's see if I can get this right. So what I'm doing is I'm going into a folder called MTA and I'm now running that same query, but I'm doing it as a for loop to look at every packet capture in a folder. So I do CD, fingers crossed, M, tab, no, T, tab, got it. So I'm inside this folder, and if I do an ls, that's how many files are in this. So there's quite a lot of files in there. Imagine going through Wireshark one at a time, trying to find all the web addresses in those files. So what we can do is, using that same concept, I apologise, I can't increase this field here, but what you're doing is, the first line is creating a listing of all the files in the directory, saving it one at a time in this variable called cat file. Then I'm doing the TCP dump replay, just what we saw before. And I'm going to pull out all my, excluding my ACK and sequence, and I'm going to do a search sort unique, and then I'm going to do a extraction of just the English names. And if my latency doesn't kill me, woohoo! And now it's pulling out all of these names that are partly English. And so we can now get like this one, www.onlinedatingforlife or .info. Someone's not doing the right thing at work, maybe, or at university. XXX.delope.at. So you can now start seeing what your users are doing on your network without having to buy expensive tools. There are lots of tools out there that you can buy that will do this for you. Or looking at your DNS servers. I like this one, working-from-home.ga. So you now can extract out, and it gives me, based on my for loop, it's showing me what the file is that it's getting this information from. So instead of just correlating it as one big list of URLs and then you don't know where you captured it from, especially if you've got multiple sensors, you want to know which file you got it from. That way you can then go and look at what's happening. And I'm going to see if I can scroll up. Sometimes the scrolling doesn't work very well. So I would definitely think that this one's a bit suspicious because it's a domain name generated thing. DGA. So it's a domain generation algorithm where they randomize the URL to try and bypass your security systems. Any questions about that? So we've covered quite a lot of information today, haven't we? We've gone from the manual process of yesterday, looking at tools that help to automate that, and then going back to the command line tools to script some of it as well. A lot of information. I'm going to go back to the Menti and then we'll finish for the day. So I hope I answered that question, Suricata versus Security Onion, what the difference is. There's all these built-in tools. How to deploy Suricata with multiple sensors. I haven't written a lab for that, but essentially you're pointing it to a log backend. And then that log backend is where you then point another Suricata system to read. But it comes back to whether you want to do the processing on the sensors or you want to do the packet capture and centralize the packet captures. So I tend to use the packet captures and then I centralize the packet captures. Some people, I'll talk to Adley, our other security guy, how he prefers it. But from my point of view, I think I like the raw packet captures being centralized because then it's easier to grab that information. Can you give a tentative research question ideas on detecting the attacks or detection of honeypots using any classifiers or any other? No. It's your research idea. You come up with it. But I gave you an idea. You could do the internationalized GREP searching. But yeah, it's difficult. And there's one other question. What about international domain names? Are they displayed in Punycode or in UTF-8 encoding in these tools? I have no idea. There's your research project. I realised when I started doing the grep searches because of LKNOG, where Champika and other people have talked about internationalisation of the domain names, I need to start updating my queries. Maybe whoever's doing the research project can help me. Any questions?